What do we call it as a linked list? Good. So far, what we are using is kind of arrays. And you know that arrays are great data structure. Rather, trust me, arrays is, Deepak has got some question. Can we use recursion in the insertion sort? Deepak, yes, you can. See, finally, मैंने आपको कल ही recursion already पढ़ाया था. And I said that it is a divide and conquer technique. So in any problem where you can apply the divide logic by yourself, you can always convert it into the recursion. तो सर insertion sort में recursion हो सकता है क्या? My answer is yes. And if you want, go ahead and try to do it. Is that okay? I'm not really going to, show it in a class. I do not really want to confuse everyone. Anyone you are interested, please go ahead, do it. If you could not do it, let me know personally. I can help you. No problem. Regarding. चलो अब हम लोग आप थोड़ा सा पीछे जाते हैं and we will talk about something. Linked list definitely I want to learn. Linked list definitely I want to learn. But before I go ahead with the linked list, many time what people ignore is arrays. मैं फिर से बता रहा हूँ, arrays are fastest data structures and arrays are like most commonly used data structures. बहुत बार हमको पता नहीं होता, वो बात अलग है, but arrays are data structure, commonly used data structures. There are some special properties of arrays. And very first property of an array, can you please tell me what is the special properties of arrays? What are the special properties of arrays? How you will say that? What are characteristics of arrays? The very first characteristic of an array, अगर आप लोग abstract data type के point of view बात कर रहे हो, definitely you can say that it can provide you random access. What is random access? You say that I want to access fourth element. You say that I want to access 10th element. You said I want to access 1000 element. You access any element at any moment. It is absolutely allowed. It is random access. The second one. Second characteristic, I can say that yes, obviously the random access is always a fixed time. Fixed time. The second important thing you talk about is the size is fixed. It is fixed size. A fixed size simply means that you cannot change the size of allocated array. आप लोग allocation, see, you can do the static allocation, you can do the dynamic allocation. Whether you allocate statically, as far as C++ is concerned, you can always allocate the array statically. Where you write that int arr of 5. So it is static allocation. लेकिन अगर आप लोग C++ या C में करते हो तो अगर malloc या new operator are there using which you can also allocate it dynamically. So what I'm saying is that let it be the static allocation, let it be the dynamic allocation, let it be the static allocation, let it be the dynamic allocation. While creating an array, you need to specify the size. And the size, once you created array, thereafter size is going to remain same. You cannot change the size of existing array. That is the meaning I say fixed size. So in other words, I'm saying that this cannot grow or shrink at runtime. After creation, इसको grow or shrink करने का कोई chance नहीं है. This is there. Then you continue further. You got a third point. What is third point? As someone has said, internally arrays are contiguous allocation. Now, but this is like internals. Definitely, that is fact. The arrays are contiguous allocation. Now, these are 2-3 points that you must be knowing with the arrays. एक और चीज, going ahead. क्या पर गया? A random access, one. Fixed size, yes, second. Contiguous allocation is third. And I'm saying that there are no overheads. No overheads. No overheads का simply मतलब है no extra space required other than data elements. So अगर हम लोग कह रहे हैं कि मुझको array of 4 integers करना है, अगर मुझको array of 4 integers करना है, then array of 4 integers will take 40 bytes. Assuming that एक integer का size है 4 bytes, so array of 10 integers will take 40 bytes. It will not take 42 bytes or 44 bytes or 50 bytes. It will not take any extra space. So there are no overheads are there. These are certain highlights that you should be knowing. And since it is random access, since it is contiguous access, you can always find it that it is like a faster. It is faster. Rather, the fastest data structure is array itself. तो जहां जहां पर पॉसिबल है, आई ऑलवेज रिकमेंड दैट गो विद द एरे. अननेसेसरी शाइनिंग मारने की जरूरत नहीं है कि मेरे को लिंक लिस्ट आता है. अगर आपको पता है नंबर ऑफ एलिमेंट्स आपके कभी चेंज नहीं होने वाले, देन यू ऑलवेज लुक फॉर गो विद द एरे. मेक इट कंफर्टेबल. मेक इट अननेसेसरी फैंसी कोड लिखने से आप कोई इंटेलिजेंट नहीं हो जाते. जहां पर जरूरत है जरूर लिखना, लेकिन जहां पर जरूरत नहीं है, अगर एरे से काम बन सकता है, आई ऑलवेज रिकमेंड दैट गो फॉर इट. नाउ I'll give you a scenario. Again, as I said that, मैंने आपको पहले लेक्चर में बताया था, this data structure is all about thinking process. It is all about thinking process to start with. So let's say that I have got a class of 50 students. I have got a class of 50 students and I want to store all 50 students. What should I use? Which data structure is probably most suitable? It is a class of 50 students and yes, I want to store them. Yes, array is like most suitable data structure because मुझको पहले से पता है this is a class of 50 students. Acha, what if I have got, let's say I have got 10,000 alumni. I have got 10,000 alumni and I want to store the information of all 10,000 alumni. What should I do? Again, please go ahead with the array because you already know that there are 10,000 alumni are there. So this is again very simple one. Okay, I'll just go ahead. Now listen carefully. Now listen carefully. Now I'm looking for, let's say that we have sent email to all our alumni for something called as the alumni meet. So we have made a alumni meet, and in case of alumni meet, we send jitne sare alumni hai, we send emails to all. Obviously, even though we send email to all, I'm very sure not all can come. Why not all can come? Obviously the few might be like out of station, few might be busy into their own work, few might be busy with their family. There are a number of things are there, you always know. So now you, let's say that the people, the alumni, they are coming one after another, and now as the people who are coming to the alumni, I want to store their information. एक एक बंदा आएगा, मुझको उसकी information store करनी है. एक एक बंदा आएगा, मुझको उसकी information store करनी है. Now in this particular case, what should I use? Should I use array in this case? Someone is saying dynamic array, but even in dynamic array, I cannot go with the dynamic array because dynamically allocate करने के लिए भी आपको size पहले पता होना चाहिए. So let's say that you see that कि अभी आपको गेट के ऊपर 3 लोग दिख रहे हैं, तो you are allocating array of only 3. So probably even by the time these people are entering, next 10 come together. So you want such a data structure where the size will vary. The size will vary. Probably ऐसा भी कुछ हो सकता है that you find someone कि like एक कोई तो आता है and then say that okay, so you just immediately allocate the memory for it, and then he said that oh no, I'm not Sanmim alumni, I was searching some other address, and then you realize that अरे यार इसको हम लोग unnecessary add कर रहे हैं, so you might want to even delete that. So not only you want to grow it, sometimes you have done some wrong entry, you want to also shrink that. You want to also shrink that. So अगर आपको ऐसा डेटा स्ट्रक्चर चाहिए, please note that array cannot be helpful. And for such kind of data structure, you need something new. You call it the linked list. I hope I tried to told you why linked list. So when arrays are there, why to go for linked list? The reason is there. Naneshwar saying that, but sir, without giving size, we can also create dynamic array. So this may also possibility. Naneshwar, I don't know how to allocate the array dynamically without giving a size. Can you please help me with the code? How do you write it? Array dynamically allocate कैसे करते हैं without giving a size? I never came across such kind of code. You came across any kind of code? अच्छा ओके ठीक है, नो प्रॉब्लम. सो सॉरी. हाँ हम लोग कहाँ पर थे? सो नाउ दिस इज अ सिनारियो वेर यू गो फॉर लिंक लिस्ट एंड व्हाट योर लिंक लिस्ट इज सेइंग. लेट मी जस्ट गो अहेड. Linked list is a list of items linked together. Oh, again a very diplomatic definition. मैंने मैंने पहला diplomatic definition आपको बताया था शायद. What definition I told you? Data structure is the structure of a data. And now you ask me what is linked list? I simply say that linked list is a list of items, they are linked together. A kind of an example that can be given. You ever heard of something called treasure hunt? You ever heard of treasure hunt? What is treasure hunt? The treasure hunt where you see that, so there are, certain clues are given. So you find that there are like certain places, and then from each place you get some clue, and from each place you get some clue. You get a clue, you go to the next. You get a clue, you go to the next. You get a clue, you go to the next. And finally, somewhere you see, oh, there is some treasure. There is some treasure. This is something that you are trying to look for. तो ये जो है, this is a real world kind of example. You can say it is a linked list. What is a linked list? Like a treasure hunt. That at any moment you do not know which is your last element, or any moment you do not know what is your third or fourth element. At every place, we are going from the first place, we are getting a clue from there, we are going to the second, we are getting a clue from there, we are going to the third, we are getting a clue from there, and then we are going to the next, and this way you are continuing everywhere. This is what a real life example. But in this case, linked list में इसको क्या कहते हैं? Each item is referred as a node. Each item is referred as a node. And then what node contains? Oh, each node contains some data. Each node contains some data, and it contains reference to the next node. So you have written a word pointer there. हाँ, I have written a word pointer there. So C++ के लोग probably pointers कहते हैं. And the people who come from a Java or C# background, who has got misunderstanding that Java doesn't have pointer, they use the word references. कोई बात नहीं. So I'm saying that each node contains the data and it contains the reference to the next node. So ultimately, you understand that like array, linked list is also the linear data structure. But then you ask the question, what is the advantage of linked list over the array? Or advantage of linked list over the array? The biggest advantage. What is the biggest advantage? The biggest advantage is that it can grow or shrink at runtime. Isn't it? Yes, it can grow or shrink at runtime. So specially लोग लिंक लिस्ट तब यूज करते हैं, जहां पर आपको नंबर ऑफ एलिमेंट्स पहले से पता नहीं है. आपको नंबर ऑफ एलिमेंट्स आपके ग्रो भी हो सकते हैं, श्रिंक भी हो सकते हैं. प्लीज नोट, एरे का साइज कभी भी चेंज नहीं होने वाला. जो कुछ भी एरे का साइज है वो हमेशा फिक्स ही रहने वाला है. इवन दो यू हैव गॉट एरे ऑफ 10 एलिमेंट्स एंड नाउ यू से दैट आई डोंट नीड 3 एलिमेंट्स, you don't need 3 elements, you will not going to change the size from 10 to 7. It is not possible. I'm saying that with the linked list, the elements जिनकी जगह आपको नहीं चाहिए, आप उनको रिलीज कर सकते हो. That is definitely the positive side of a linked list. But at the same time, there is some negative side as well. What is the negative side of this? In linked list, ये treasure hunt है. Since it's a treasure hunt, directly jumping on a last node or directly jumping on an in-between node is not possible. So I'm saying that this is only good for sequential access. This is only good for the sequential access. ये सिर्फ sequential access ही दे सकता है, ये आपको random access नहीं दे सकता. That is unfortunate. I hope you got that point. So यहाँ पर, so I want to jump on like nth element. It is not possible. Not possible in the sense it is slower process. Let's say that a given a place. So मुझको चौथे element पे जाना है. Can I go to the fourth element? Yes, you can go to the fourth element, but not directly. You want to go to the fourth element, go to the first, second, third, fourth. So I'm saying that the sequential access only. हाँ, traverse करके जा सकते हो. Random access is going to be slow. That is second. What is third thing? What is third thing? The another, probably you can say drawback. You can say that overheads. Overheads. What is overheads? So I'm saying that you have got each pointer, each node has got a pointer to the next node. Each node has got a pointer to the next node. So when you say that हर एक नोड में आपको कुछ ना कुछ तो रेफरेंस रखना है, हर एक नोड में आपको कुछ ना कुछ तो रेफरेंस रखना है, तो अगर आपके पास 100 नोड होंगे तो आपके पास 100 रेफरेंसेस एक्स्ट्रा होंगे। अगर आपके पास 10,000 नोड होंगे तो 10,000 रेफरेंसेस एक्स्ट्रा होंगे। जस्ट फॉर योर इंफॉर्मेशन, आई होप आपको ये पता है, द रेफरेंसेस आर लाइक पॉइंटर्स। references are like pointers, they are also going to take some memory, 4 byte memory, 8 byte memory, कुछ ना कुछ तो memory वो अलग से लेने वाले। So I'm saying that you just think of it कि आपको array of integers बनाना है, आपको array of integers बनाना है, 10 इंटीजर का कर आपको array बनाना है, 10 इंटीजर का array बनाना है, आपको सिर्फ 40 बाइट लगते हैं। लेकिन अगर आपको 10 इंटीजर की लिंक लिस्ट बनानी है तो इंटीजर के लिए तो 40 बाइट लगेंगे, प्लस 10 एक्स्ट्रा पॉइंटर्स आपको लगने वाले हैं। और जो 10 एक्स्ट्रा पॉइंटर्स आपको लगेंगे उसकी साइज लेट्स से अनदर 40 बाइट्स और अनदर 80 बाइट्स, दीज आर द ओवरहेड्स फॉर यू एंड नथिंग मच यू कैन डू। नाउ व्हेन इट कम डाउन टू द लिंक लिस्ट, व्हेन इट कम डाउन टू द लिंक लिस्ट, व्हिच ऑपरेशंस, यस ऑब्वियसली ये बताने की जरूरत नहीं है कि लिंक लिस्ट की जो भी मेमोरी आएगी, द लिंक लिस्ट मेमोरी इज नॉट कंटिग्यूअस। लिंक लिस्ट, इट इज नॉट contiguous allocation. Linked list memory is not contiguous allocation. Please understand this. So I talked about what is linked list. I talk about, let's say, arrays. It is there. And now it's time to talk about linked list as an abstract data type. ये हमने कल के लेक्चर में पढ़ा था, abstract data type. Every data structure is kind of abstract data type only. And if it is abstract data type, what are the common operations? What are the common operations that can be performed on a linked list? I said that the common operation that can be performed is, let's say, add first, saying that I want to add the element at the beginning. Add last, I want to add the element at the end of the linked list. I want to add the element at the given position in a linked list. I might want to delete the element at the start. I might want to delete the element at the end. I might want to delete the element at the given position. I might want to delete all the elements. I might want to delete all the elements. So not only that, if you at all look for extra, you might think of a method like traverse, or you may consider even a simplified method, let's say display, and so on and so forth. आपको जो चाहिए वो आप लोग यहाँ पर डाल सकते हो. This is absolutely possible. Now these are commonly used operations. और जहां तक मुझको पता है, आपको ये अलग से बताने की जरूरत नहीं है. You people have learned Java. जावा के अंदर जावा का खुद का एक लिंक लिस्ट का क्लास है. जावा का खुद का लिस्ट इंटरफेस है, which is already telling you which all operations are there. Obviously the names might differ. So जावा में कुछ तो add first, add last, sorry, हमारे यहाँ पर हम लोग add first, add last ऐसे नाम यूज कर रहे हैं. They might have used the different name, the names like add, name like insert, name like some of the remove. तो उन्होंने अलग अलग नाम यूज किए, उससे कोई फर्क नहीं पड़ना चाहिए, right? Let us take a look at what all different types of linked lists are there, and then we will take a break, so that after the break we will focus only on implementation. So we say that commonly speaking there are 4 types of linked lists as far as the internal structure is concerned. Which are 4 types of linked lists? The first type of linked list, we call it a singly linear linked list. What is singly linear linked list? You find it over there. In a singly linear linked list, the first node, each element is a node. Each element contains 2 things: data and pointer to the next node. This is a node. Each element contains data and pointer to the next node. Data and pointer to the next node. This is how you are trying to make a linked list. Now, how the things are doing? You find it there. This is nothing but the head pointer. Head pointer is a special pointer. Head pointer is a special pointer that keeps the address of the first node. Sir, ये 100, 200, 300 क्या है? I just written some numbers to indicate the addresses. So it is head node is pointing to the address of the first node. It is 100, and then it contains the address of the next node, which is 200, which contains some data and a pointer to the next node, which is 300. And this is a singly linear linked list. Last element in this linked list is null. Null in the sense It is not pointing anywhere. You can say that कि this is your end of your treasure hunt. अब यहाँ से आगे आपको और कहीं पर जाने की जरूरत नहीं है. Singly linked list. Why it is singly? Because each node hold a single reference to the next node. Why it is a singly linked list? Because each node hold a single reference to the next node. But other way around, there is also something called a doubly linked list. What is doubly linked list? The doubly linked list, you should be able to see it over here, something similar. Each node, each node contains data and pointer to the next node. Data and pointer to the next node. Data and pointer to the next node. So ये तो पहले भी था. अब नया क्या है? Now extra thing is that each node contains a pointer to the previous node as well. So what exactly it means? Have a look at this. पहले basic. Head node is containing the address of the first node. Good. The first node containing address of next node. This node contains the address of next node. Last node contains null. Okay, that is quite good. You go in the other way around. Other way around, what is that? The last node is containing the address of the previous node. This node is containing the address of even previous node. And the first node is again, it is null node. Here, each node contains data and pointers or references of two nodes. One is next, another is previous, and that is the reason this is said to be doubly linked list. This is said to be doubly linked list, doubly linear linked list at the moment. You continue further. The next part, we are saying that singly circular linked list. So what is circular linked list? It is like, अगर आप लोग singly linked list की बात कर रहे हो, it is like this linked list only. However, singly linked list only. Over here, this is pointing to the first node. The first node is keeping address of the second node. Second node keeping the address of the third node. But the last node, you see that it is not null. It is keeping the address of the first node. And this part is nothing but circular. What is circular? Circular simply means that the last node contains the address of the first node. Last node contains the address of the first node. You start calling it as a circular linked list. So sir, is it possible to have doubly circular as well? Yes, doubly circular as well, where last node keeping the address of the first node and first node keeping the address of the last node. That's it. Rest everything is very simple. These are four different types of linked lists. This is singly circular, this is doubly circular. I hope ये आपको already सुन के पता होगा. I'm very sure. Have you people written any simple linked list in Java? जावा में आपने कोई बेसिक लिंक लिस्ट लिखा था क्या जावा के मॉड्यूल में? यस. कुछ लोग यस कह रहे, कुछ लोग नो नो कह रहे. सो कुछ कॉम्बिनेशंस आर देयर. कोई बात नहीं, वैसे भी हम लोग डेटा स्ट्रक्चर पढ़ रहे हैं, तो वैसे भी विल हाँ सिंगली लिंक लिस्ट whatever कोई भी लिंक लिस्ट हो उससे कोई फर्क नहीं पड़ता. वैसे भी वी आर गोइंग टू राइट इट फ्रॉम स्क्रैच ओनली. सो वी आर गोइंग टू टॉक अबाउट हाउ टू राइट द नोड, हाउ टू राइट द लिस्ट एंड लाइक ईच एंड एवरी पॉइंट. डब्ल्यू लिंक लिस्ट, here you go. What is the doubly linked list? The doubly linked list is one where each node contains the address of the next node. Each node contains the address of the next node, but at the same time, each node contains the address of the previous node. Each node contains the address of the previous node. I hope Amit that is clear. हर एक नोड के अंदर आपके प्रीवियस नोड का भी एड्रेस रहता है. दैट इज व्हाट यू कॉल इट एज अ डब्ली, दैट इज कॉल्ड एज अ डब्ली लिंक लिस्ट. सिंस देयर आर टू पॉइंटर्स, दैट्स व्हाई इट इज रेफर्ड एज अ डब्ली. नथिंग ग्रेट, डोंट वरी. वैसे भी हम लोग इसका प्रैक्टिकल करने ही वाले, हम लोग हर एक लिंक लिस्ट का प्रैक्टिकल करने वाले. टू स्टार्ट विथ ऑब्वियसली विल फर्स्ट स्टार्ट विद द सिंगली लिंक लिस्ट. विल राइट अ प्रोग्राम फॉर सिंगली लिंक लिस्ट. Listen, before you take a break, usually my method of teaching data structure is very simple. The first linked list I teach at most slow rate. जिस स्पीड से आप लोग कहोगे उस स्पीड से हम लोग पहला लिंक लिस्ट पढ़ेंगे. बिकॉज जिसको पहला लिंक लिस्ट आ गया, जिसको पेपर वर्क आ गया, जिसको एल्गोरिथम डेवलप करने आ गया, दैट पर्सन कैन ऑलवेज राइट द कोड फॉर अदर लिंक लिस्ट. सो Today, I'll be focusing, rather, it is absolutely fine, even though we learn a single linked list till the end of the day today. It is absolutely no problem. So we will go very slow. Any questions are there? Your every question is welcome today. You understand, you ensure that you are able to do the paperwork with me. Any paperwork is not clear, any line of code is not clear, please do ask immediately. We will sort out this. I'm talking mainly to those people who are still weak in linked list or like never learn linked list before. ऐसा होना नहीं चाहिए आइडियली, क्योंकि आप लोगों ने सीकेट एग्जाम दिया है, बट स्टिल सर तब नहीं पढ़ा था, तब सिर्फ रट्टा मारा था, वट एवर. दिस इज आइडियल लेक्चर. डू नॉट एक्सपेक्ट मी to go like every next linked list in equally slow speeds. So usually first 2 hours we will learn probably one linked list. Next 2 hours we will learn rest three types of linked list. So please be prepared for that. So today's lecture, lab after that, and paperwork. This is very important if you want to understand the tomorrow's lecture. So be prepared mentally, have a cup of tea, make yourself fresh, and then we will continue further. Let's go. I'll just put a timer. I hope you are there. And let us get started with linked list. And as I said that we will be learning all these linked list, not only conceptually but also practically. What is important is to understand how do we draw the diagram and how do we build a code from that. The technique remains same. The technique remains same for all the linked lists. And trust me, not only that, the same technique continued further for the trees or even graphs as well. I do recommend that if you are already expert into the linked list, still take linked list seriously, do all paperwork once again, make yourself comfortable, and see whether you can build the code from the diagram. See, usually people by-head the code. That is not really a good idea. Linked list is probably the easiest data structure where you learn how to draw the diagram and how to build the code on the fly. So if you get a skill of building the code on the fly, I believe you have conquered the data structure, right? But if you miss that, then there is a problem. Then जैसे जैसे मॉड्यूल आगे जाता है, जैसे like linked list कुछ लोग रट्टा मार के मैनेज कर लेते हैं, and then they find trees very difficult, they find hashing even more difficult, they find graph is impossible. So this is ideally time, and you are lucky that you are getting a new year gift like linked list. So today and tomorrow we'll be talking about a linked list, the greatest gift ever. So getting back, we will continue further, and we will start talking about singly linked list, the actual implementation. So what we will start about, we will see, as I already told you, linked list is basically the abstract data structure. Abstract data structure, so internal implementation may vary from type to type linked list. It may vary from programming language to programming language. What will remain same, what will remain common are the basic operations. So what I'm planning is that we'll start with all operations one by one, and then for each operation we will see how we can implement that, right? So let us just get started. And very first concept that I need to talk about before we even go ahead, that how this linked list is to be represented in an object oriented world. Okay, in an object oriented world, how this linked list can be represented. क्योंकि पहले लिंक लिस्ट अगर आप लोग रिप्रेजेंट करोगे, तब जाके बाद में हम लोग सोचेंगे इसका कोड कैसे करना है. पहले लिंक लिस्ट को रिप्रेजेंट करने आना चाहिए. तो you understand that right now what we say that linked list is list of nodes connected to each other. If I say that linked list is list of nodes connected to each other, the very first thing the very first thing that I see is that it is in object oriented world. You can say that linked list is like a class. You can say linked list is like a class. So you can say that you can have a class which is representing a linked list. a class which is representing a linked list, and then will have all its operations. Now, what sort of operations? Just now you see that the operations are like, अब मैं बार बार पब्लिक नहीं लिखने वाला, इसलिए मैंने एक बार लिख दिया है. You see that rest, it is, you can consider it for all together, right? So which all operations? I'm saying that one of the operation like display operation, another operation like add first operation, another operation like del first operation, another operation like add last operation, another operation like added position operation, and this way there will be number of operations that we will be writing one after another. The question is that what should be there into the data? Or data is nothing but linked list. And what is linked list? Linked list is list of node connected together. A linked list is list of node connected together. So very first question that you should be having is that what basically one node is. You see it very well that node has got two parts. Each node has got two parts. One is the data and another is kind of a pointer to the next. One is the data and another is pointed to the next. तो सर डेटा कौन सा टाइप का होगा? जिस टाइप की आपको लिंक लिस्ट बनानी है. अगर आपको लिंक लिस्ट इंटीजर की बनानी है तो शायद आपका डेटा इंटीजर होगा. अगर मुझको लिंक लिस्ट एम्प्लॉय की बनानी है तो देन डेटा शुड बी लाइक एम्प्लॉय. अगर मुझको लिंक लिस्ट प्रोबेबली लेट्स से स्टूडेंट की बनानी है देन द डेटा विल बी लाइक स्टूडेंट. So it is up to you, but ultimately you understand that each node contains two things. Each node contains two things, and linked list, the linked list, when you say linked list only contains the starting address that is referring to the first node. Thereafter, you see that each node contains the address of next, each node contains the address of next, each node contains the address of next. So अगर आपको लिस्ट को रिप्रेजेंट करना है तो उससे पहले हमें क्या पता होना चाहिए? वो उससे पहले हमें पता होना चाहिए what is, let's say, class node. And what should be there in a class node? Or class node, there should be two data elements. One, some data, whatever a type कौन सा चाहिए वो आप लोग डिसाइड करो, of any type. So there should be a data, there should be a data. And the second thing, I want a reference to the next node. I want reference to the next node. That is something I'm looking for as far as data is concerned. Please note, this is nothing but data. And as far as operations are concerned, you can write your basic operations like constructor. You can write the basic operations like getter setters if you are interested in. So वो आपकी मर्जी है वो आपको क्या क्या लिखना है. But that is what you can make a class node. So node, each node contains two parts. One is the data and then pointer to that. And what is the linked list? The linked list, I simply say that the linked list is nothing but address of the first node it contains. So address of a first node, you can simply make node head. You know that this head is nothing but ultimately going to be a pointer. So this is going to be my data and these are going to be my operations onto the linked list. So ultimately, when we make a linked list, ultimately, when we make a linked list, the linked list will be represented in OOP world using a linked list will be represented in OOP world using a class. The class list having some data, and then rest of the operations. You continue further, but each node itself is a kind of a class. Itself is kind of a class, and then it will have its own data in it. And obviously the operations are always there that we will be implementing one after another. Now my first question is that listen carefully. और अभी जावा का थोड़ा सा रिवीजन चाहिए क्योंकि अल्टीमेटली हम लोग डिसाइड कर रहे हैं कि इसको जावा से बनाएंगे. तो कैन यू प्लीज टेल मी, आई कैन ऑलवेज सी दैट लिस्ट has got multiple nodes, so kind of has a kind of relationship is there. My question to you is that क्या नोड बनाने के लिए लिंक लिस्ट का ऑब्जेक्ट होना जरूरी है? इज इट नेसेसरी? नोड बनाने के लिए लिंक लिस्ट का ऑब्जेक्ट होना जरूरी है? एब्सोल्युटली नो. नोड इज नोड एंड लिंक लिस्ट इज लिंक लिस्ट. Obviously they are related, but then once linked list object is created, then nodes can be added into that. So the best mechanism that is usually followed when it comes down to the Java, we say that these are connected to each other. How? So inside list, you make it as a static member class. Inside list, you make it as a static member class. Static member class. So what is the advantage of making static member class? Why not to make it as a separate class? If you make it a separate class, typically your data member will be private, and the private data members you will be always accessing, with the getter and setter and all that kind of complications. It is not really required. Typically, even node class, that usually makes sense only with the list class, isn't it? So it is always a common practice when it comes down to the Java. I'm going on a Java specific. When you come down to the Java, it is always a common practice that you make a node class as a static member class of this. If you ever come from C++ background, तो C++ में हम लोग static member class बनाते हैं क्या? C++ में nested classes का कोई टॉपिक ही नहीं है. तो वहां पर नेस्टेड क्लासेस होते हैं, बट नॉट लाइक जावा, स्टैटिक मेंबर क्लास, एनोनिमस इनर क्लास, दैट काइंड ऑफ टॉपिक इज नॉट देयर. सो इन सी प्लस प्लस अ वेरी कॉमन मेथोडोलॉजी इज टू यूज अ कंसेप्ट ऑफ फ्रेंड क्लासेस. तो वहां पर हम लोग लिस्ट क्लास को नोड क्लास का फ्रेंड बना दें. नाउ these implementations usually goes language specific, and a standard practice in Java, जब भी आपको बनाना है, so you make first of all node class, and that node class should be the member class of your list class. Member class of your list class. और वो भी कैसा member? A static member class. फिर से एक बार, आपने ऑलरेडी नेस्टेड क्लासेस पढ़ लिया है, मैं फिर से एक बार बता रहा हूं, why it is static member class. Why it is static member class? Because I'm saying that to create to create object of node to create object of node, having object of my list is not mandatory, mandatory, and that is the reason you go for static member class. If at all is the case, नहीं से inner class का object बनाने के लिए outer का object होना जरूरी है. In that particular case, we go for नॉन स्टैटिक मेंबर क्लासेस. अगर आप लोगों ने जावा में इटरेटर पढ़ा है, तो टिपिकली इटरेटर्स आर क्रिएटेड एज अ नॉन स्टैटिक मेंबर क्लासेस. लेकिन जाने दो, हमारा इटरेटर अपना टॉपिक नहीं है. आई एम जस्ट ट्राइंग टू टेल यू कि व्हाई आई एम गोइंग टू इंप्लीमेंट इट लाइक दिस. वापस से ये आपको एक ही बार समझना है, क्योंकि सिंगली लिंक लिस्ट में जो स्ट्रक्चर करेंगे उसको कॉपी पेस्ट करेंगे और बचे हुए लिंक लिस्ट खत्म करेंगे. जो कंसेप्ट हम लोग लिंक लिस्ट में फॉलो करेंगे, एग्जैक्टली सेम कंसेप्ट हम लोग ट्री में भी फॉलो करेंगे. सो इट इज लाइक वन टाइम एफर्ट्स टू अंडरस्टैंड how to organize your code. So now, since I have understood a lot of organization now it's time we'll go back. As you see that break में मैं थोड़ा सा टाइम पास कर रहा था. टाइम पास ये कर रहा था because usually students like, so why you don't take the input from the user and all that. So I thought of taking the output. Amit, whatever I discussed was part of your Java code, and you people have already learned it into the Java. Static member class, non-static member class, iterator class, node class, whatever is relevant over here, I'm just telling you. You can go back and revise your lectures of Java if you need it. I'm just going back. I'm saying that class singly list. The class singly list, and this list class, I want to make it as a node class. Node is static member class of singly list. You go ahead. So static class node, static class node. What all I need? I need the data members. अभी मुझको इंटीजर का लिंक लिस्ट बनाना है. अगर मुझको इंटीजर का लिंक लिस्ट बनाना है, I should simply say private int data. You continue further, and again you say private node next. All right, this is done. Going ahead, public node, and then inside this constructor. A constructor may, let's say data, I want to keep it 0. Let's say next, it is a pointer, I'm keeping it null. All right, you continue further. If you want, you can also think of having a parameterized constructor. The parameterized constructor where you are taking a value for the data and you are assigning that. I believe that such simple node class should be more than sufficient. Such simple node class is more than sufficient. And then we can continue on to the list members. So now I'm saying that singly list class data और data members, इसको हम लोग कहते हैं fields. मैं यहाँ पर भी कमेंट लिख दूं आपके लिए, node class fields, and then you go ahead node class methods. आई एम गोइंग अहेड। ये आपका स्टैटिक मेंबर क्लास था। आई वुड सजेस्ट दैट इसको एक बार लिखो और एक बार लिखने के बाद में इसको मिनिमाइज करके रखो, क्योंकि वैसे भी आपको उसको बार बार एक्सेस नहीं करना है। एंड देन यू ओनली नो दैट देर आर टू डेटा मेंबर्स, वन इज डेटा अनदर इज नेक्स्ट। इसके अलावा कोई आपको दिमाग लगाना है ऐसे मुझको तो नहीं लगता, राइट? सो यू कंटिन्यू फर्दर एंड देन यू डिक्लेयर द फील्ड्स। what is the field over there? I do not want to access it outside the class, so this node is nothing but as a head. गुड। और जब मेरा प्रोग्राम शुरू होगा, जब मेरा प्रोग्राम शुरू होगा तो इनिशियली मेरे लिंक लिस्ट में क्या रहेगा? जब मेरा प्रोग्राम शुरू होगा एट दैट टाइम मेरे लिंक लिस्ट में कितने नोड रहेंगे? कुछ भी नहीं रहेगा। अगर कुछ भी नहीं रहेगा तो वेयर हेड विल पॉइंट टू, और वेयर हेड विल पॉइंट टू, हेड विल पॉइंट टू प्रोबेबली null. So you go ahead and you write a constructor. Within a constructor I want to simply say head is equal to null. A few people might be worried, sir, why you are not writing this dot head? This dot head, again, using this into the what is that, classes, into the member function is always a good practice. Using this is always a good practice, no doubt on that. But I do not want to make my code complicated. I really do not have any habit of teaching other technology while teaching this. So जब मैं जावा पढ़ाता हूँ, at that time I focus कि what are the good OOP practices, what is this pointer, तो ये ऐसा करना चाहिए, वैसे करना चाहिए. When I probably come down to teach data structure, I usually focus onto the data structure part, right? So writing this is not compulsory, and in my opinion, many times using this every time in a data structure code, usually it deviates स्टूडेंट्स का प्रॉब्लम होता है कि वो दिस कहाँ पर लगाना है, दिस कहाँ पर नहीं लगाना है, उसमें इतना ज्यादा वक्त बर्बाद करते हैं कि जो डेटा स्ट्रक्चर का जो मेन एल्गोरिथम रहता है वो छूट जाता है. सो आई जस्ट वांट टू कीप इट सिंपल. आई जस्ट से दैट आई हैव डिक्लेयर डेटा मेंबर एंड आई एम राइटिंग हेड इज इक्वल टू null. And then I'm going to write all the methods inside list class. So which all methods that I want to write? Oh, I want to write a method like a display. It's like one method. Probably I want to write a method of like say add first, like another method, the new node that I want to add. I want to probably add another method like say add last, एंड सो ऑन सो फोर्थ. तो आपको जितने सारे मेथड चाहिए उतने सारे मेथड्स हम लोग वन आफ्टर अनदर ऐड करने वाले हैं. मैं सारे एक साथ नहीं लिख रहा हूं. आई डू नॉट वांट टू कंफ्यूज यू. सो बट वी विल गो अहेड, वी विल टेक अप वन मेथड एट अ टाइम. We will do the paperwork of that method. We will try to build a logic on paper, and once we build a logic on paper, then we will continue from there. We'll continue from there. This is what we will follow. Let me just check if there are any question. Was there any earlier? I means why we are not using object there. Why we are not using object there? We are using object there. वैसे भी जब भी हम लोग node create करेंगे, we have to create a node and we have to create object of a node. We have to create object of a node. Hold on, let me continue. Let me create a linked list. दो चार operations हो जाने दो. I hope the things will be clear. Things will be clear. Not a problem. If things are still not clear, so definitely, if some topics are like out of the track, we can always discuss it at the end of the lecture. So I usually wait for you people, so you know that, not a problem. But then over here, let us focus on data structure at the moment. चलो हम लोग कहाँ पर थे? So I was saying that this is ultimately the singly linked list, the class we have written. And then whatever operations that you want to do, see, you cannot do the operations on a class. Do understand that you have to do operations onto the, you have to do the operations onto the object. So somewhere you have to go ahead and you have to create the object of a singly linked list. Somewhere you have to create object of the singly linked list, and once you created object of a singly linked list, then you need to call all your methods on that object one after another. Somewhere you say that list dot display, yes you can. Somewhere you want to call list dot add first, yes you can. Or somewhere you want to call list dot add last, and this way you will keep adding, keep calling all methods one by one. सो अल्टीमेटली ऑब्जेक्ट हमको बनाना ही है. बिना ऑब्जेक्ट के तो वैसे भी प्रोग्रामिंग नहीं होने वाला है. बट एज आई एम सेइंग दैट लेट अस नॉट फोकस ऑन टू क्लास कब लिखना है, ऑब्जेक्ट कब बनाना है. लेट अस फोकस ऑन एल्गोरिथम एंड लेट अस जंप इनटू द कोड एंड देन वर्क ऑन टू दैट. चलो लेट अस गो अहेड. एंड द वेरी फर्स्ट एल्गोरिथम दैट आई वांट टू सी, a very first algorithm that I want to see, how do I display the linked list? People ask the question, sir linked list तो अभी तक बनाया नहीं, why you are trying to display? I'm saying that let us assume that linked list is already created. Let us assume that linked list is already created, And if linked list is already created, my question is, how do I display the linked list? But to display the linked list, I'm very sure the very first question that should be in your mind, अगर linked list display करना है, मतलब basically display क्या करना है? What I'm saying is that linked list display करना है, मतलब basically display क्या करना है? Look at the diagram, look at the diagram, and can you please tell me अगर linked list display करना है, मतलब exactly इसमें से आपको क्या display करना है? What should be the output of this linked list? अगर मैंने ये वाला लिंक लिस्ट डिस्प्ले किया जो अभी आपको सामने दिख रहा है, अगर ये वाला लिंक लिस्ट मैंने डिस्प्ले किया तो एक्चुअल आउटपुट क्या आना चाहिए? एब्सोल्युटली इट शुड बी 11 22 33. What point that I want to make it is that, so I am not interested in printing कि इसका एड्रेस क्या है, इसका एड्रेस क्या है, इसका एड्रेस क्या है. I do not bother. When I say that I want to display the linked list, I want to display the data part in each linked list. That is good. So sir, chalo, let us go ahead and let us try to display it. Try to display it. The likely chances are that you might think that, sir, wo to theek hai. I want to display the first node 11. It is very simple. Why it is very simple? Because basically head is a pointer to the first node. Head is a reference to the first node. If head is a reference to the first node, I can always say head dot data. And if I say head dot data, I can always say that, okay, print that. That will be like very simple job. So I can always have like kind of a printf function where I can print, sorry, I can have a printf function where I can write head dot data. But the problem is that this will print only the head part. What about the next node and next node and next node? By the way, how many nodes are there in linked list? I said that I don't know. It is a treasure hunt. You never know how many nodes are there. And at a time, you cannot see all the nodes. So ultimately, logic that you need to follow is that you get the address of the first node, you print that. From there, you get the address of the second node, you jump there, you print that, you print that. Again, you get the address of the next node, go there, and then print the next node, and you keep going, keep going, keep going until you reach null, which indicate that कि अब ये लिंक लिस्ट खत्म हो गया है, अब इस लिंक लिस्ट में कुछ भी नहीं है, अब इस लिंक लिस्ट में कुछ भी नहीं है. चलो, आई अंडरस्टैंड इट वेल. तो सर लेकिन प्रॉब्लम इज दैट हाउ डू आई गेट द एड्रेस ऑफ द फर्स्ट नोड? Address of the first node that you can get it in a head, oh that is always available. And how do I get the address of the next node? Oh, this node, जो कुछ भी नोड आपके पास है उसका जो नेक्स्ट मेंबर है, प्लीज नोट दैट जो डेटा मेंबर है इट इज अ डेटा, जो नेक्स्ट मेंबर है it is basically pointer to the next node, a pointer to the next node that is in front of you. So let us just go ahead and what do we do? Let us just go ahead and what do we do? To traverse the whole linked list, to traverse the whole linked list, what I will need is, what I will need is, I will declare, I will declare a special pointer. I will declare a pointer. When I use the word pointer, you can call it as like a reference. So you declare a reference called as a trav, and then you begin with the very first node. My first node is obviously 100, which you can take it from the head, which you can take it from the head. You can go ahead, you can print the travs data. Whatever is the travs data that you can print it, oh, it is working well. But then what do you want to do? What is the next part to be done? What is the next part to be done? The next part to be done, now you want to go to the next node. But what is the address of next node? See the diagram carefully. जो लोग पहली बार पढ़ रहे हैं, जिनको ऑलरेडी लिख लिस्ट आता है, आई एम वेरी श्योर आप लोगों को बोर हो जाएगा, बट नथिंग मच आई कैन डू. I am trying to go as slow for the people who are learning for first time. So please pay attention, and you have any question, please ask early. Correct? So वैसे तो सबको आता है, तो usually it happens that then I am going fast and then sir वो समझ में नहीं आया था. Please don't do like that. So यहाँ पर if the trav, I'm saying that I can always begin with trav is equal to head. Trav is equal to head. I get the address of the first node. I get the address of the first node. That is not a problem. I got the address of the first node. I simply say trav.data. I printed that. Now question is that I want to go to the next node. What is the address of the next node? Oh, address of next node is 200. But where do I get the address of the next node? Address of the next node, please make a note of this. ये यहाँ पर है. this is the data part. This is the next part. Agar trav.data, can you tell me at this moment what is trav.data? What is the value? At this moment, looking at the diagram, what is the trav.data? Yes, trav.data is 11. But can you please tell me now, looking at the diagram, what is trav.next then? Look at the diagram. Trav.next is nothing but 200. That 200, you can take it back into the trav. You can take it back into the trav. Meaning by earlier it was 100, now you make it 200. As you make it 200, I'm saying that now it is no more pointing. It is no more pointing to this node, no more pointing to this node, but now it has started pointing to the next node. It has started pointing to the next node. And then you want to again repeat the stuff. So initially, just now you have printed the 11, not a problem. You repeat the stuff. Now look at the diagram and tell me what is trav.data now. Already you have printed 11. Already you have printed 11, not a problem. My question is that what is trav.data now? Yes, trav.data is now 22. Okay, 22. So you printed 22. You printed 22. You repeat the process. Say trav is equal to trav.next. Now in this case, what is trav.next? Oh, trav.next, I see it is 300. 300 is copied back to the trav. If 300 is copied back to the this, what will happen? Now this is 300, and if this is 300, look at this. If this is 300, it will start pointing. It will start pointing to the new node. Okay, that is good. And again, probably I want to repeat the process. Again, I want to repeat the process. Now at this time, if I repeat the process once again, at this moment, what is trav.data once again? Now you find that trav.data is 33. Yes, you print 33. And again you say trav is equal to trav.next. Again you say trav is equal to trav.next. Now trav.next, you find that it is null. It is null. So ultimately, you understand that now this will be 0. This will be 0. This is not pointing anywhere. Now what do you want to do? Now what do you want to do? Do you want to repeat it further? No, I want to stop it over here. The question is, how do I stop it? How do I put a condition of my loop? The loop condition should be very simple. While trav is not equal to null. While trav is not equal to null, keep on repeating again and again, again and again, again and again. And that is the reason I'm saying that please do the paperwork. The biggest problem that usually happen with the data structure is that people tend to by heart the condition. Sir, वो trav is equal to null होता है, trav is not equal to null करना है, trav dot next is not equal to null करना है, trav dot previous is not equal to null करना है. I said that do not by heart the condition, follow with the flow. फॉलो विद द फ्लो, डायग्राम ड्रॉ करो और फिर खुद को क्वेश्चन पूछो कि मुझको कहां पर रुकना है. अगर आप लोगों ने क्वेश्चन ये बाहर किया तो लोगों का प्रॉब्लम क्या होता है? सो सिंगल लिंक लिस्ट में वी राइट ट्रैव इज नॉट इक्वल टू नल. नाउ यू गो ऑन द नेक्स्ट लिंक लिस्ट एंड पीपल से दैट सर अभी यहां पर ऐसा कंडीशन लिखा, वहां पर वैसा क्यों लिखा? डोंट डू दैट. क्या हुआ ज्ञानेश्वर? यू आर राइटिंग अ रॉन्ग कंडीशन. दैट इज द रीजन आई एम ट्राइंग टू टेल यू. आपको ही मैं बता रहा था दैट the condition should not be trav dot next is not equal to null. Condition should be trav is not equal to null. तो सर ये ऐसा क्यों होता है? यही तो मैं आपको कह रहा हूं. डू नॉट बाय हार्ट एंड डू नॉट से दैट नहीं नहीं सर ये ऐसे ही कंडीशन होना चाहिए. डू द पेपर वर्क. डू द पेपर वर्क. यू टेक अ डिसीजन स्टेप बाय स्टेप कि आपको एग्जैक्टली कहां पर रुकना है. आर यू गेटिंग? इसलिए आप लोग कह रहा हूं कि प्लीज बाहर मत करो. सर ये अब मैंने कहा ना पहली लिंक लिस्ट में प्रॉब्लम नहीं आता है, दूसरी लिंक लिस्ट में प्रॉब्लम आता है. सर उस लिंक लिस्ट में ऐसे किया था, इस लिंक लिस्ट में ऐसे क्यों कर रहा है? डू नॉट मेमोराइज द स्टफ. अब इसमें आपकी गलती नहीं है. मैंने कहा ना जो अवर इंडियन एजुकेशन सिस्टम इज रियली स्टूपिड वन. रियली स्टूपिड वन. ये मेरा पर्सनल ओपिनियन है. And that Indian education system, in my opinion, that it tell you two things: how to use your memory and how to use your IO devices. इसके अलावा जहां तक when it come down to the Indian education system, typically engineering, in my opinion, we hardly get a chance there where we use our processor. So what is processor? प्रोसेसर मीन्स ब्रेन. व्हाट अभी आप जिन लोगों के अच्छे खासे स्कोर है इंजीनियरिंग के, प्लीज गो बैक एंड ट्राई टू रिकॉल व्हाट यू अचीव्ड देयर. सो यू नो द पीपल who can memorize maximum number of answers and people who can complete the paper in a 3 hours of time, you call it IO devices, isn't it? So memory में याद करो और 3 घंटे में पूरा पेपर खत्म करो. So people who are able to do that, you know, they get the highest scores. And then people started believing. The biggest problem is that moment people by heart something, they start believing कि मेरे को समझ में आ गया है. You know, that is what taught to us. I'm not saying you, even I am from the same Indian education system only, correct? So what I have seen that, you know, our 16 whatever 14 12 plus 10 plus 2 plus 4 16 years of education, people are teaching it that if you can memorize something, it means that you have understood it. So understanding and memorizing, इन दो वर्ड्स का डिफरेंस इंडियन लोगों को नहीं आता. दैट इज द बिगेस्ट प्रॉब्लम इन माय ओपिनियन. ऑब्वियसली मेरा अपना ओपिनियन है, आपका अलग हो सकता है. यू आर फ्री. आप लोग एनालाइज करो एंड देन यू आस्क द क्वेश्चन टू योरसेल्फ वेदर यू अंडरस्टैंड द थिंग्स, whether you memorize the things. And I only request that don't do that for data structure. If you're doing it for data structure, that is your biggest mistake. With that, what you can do, you can only write the algorithms that you have written before. Moment you want to write a new algorithm, now you need understanding, you do not need the memory. I have always said that even though you forget some algorithm, that is still fine. Don't remember the algorithm. You forget some algorithm, that is fine. But you understand the way the algorithm is derived, and to not forget, you try it again and again on paper. I may not keep telling it for every algorithm, like a first time, so I'm telling you. I'm repeating the whole algorithm once again for you. एंड प्लीज नोट दैट मैं आपको कोड लिख के, और एक चीज, हाँ एक और चीज, डेटा स्ट्रक्चर पढ़ने के दो तरीके होते हैं. एक तरीका होता है रेडीमेड कोड लो, दिस इज अ कोड, यू एक्सप्लेन इट लाइन बाय लाइन एंड यू से दैट ये लाइन है इसका मीनिंग ये है, ये लाइन है इसका मीनिंग ये है, ये लाइन है इसका मीनिंग ये है. दिस इज वन वे ऑफ लर्निंग डेटा स्ट्रक्चर. The second way of learning data structure is that you do not come with the code, you do not start with the code, you start with the diagram, you start with the concept, and you draw the diagram, you build your own code. Build your own code. By the way, which method is better, the first or second? The second method is better. It is time taking, but it is worth. Always remember that. So when you come with the ready-made code, you always say that. तो वहां पर आप लोग कोडिंग नहीं सीख रहे हो, यू आर नॉट डूइंग लाइक योर व्हाट इज दैट, आप आपकी थिंकिंग एबिलिटी नहीं बढ़ा रहे हो. आप लोग क्या कर रहे हो, आप लोग आपकी एनालिसिस एबिलिटी बढ़ा रहे हो, कोडिंग एनालिसिस. अच्छा ये कोड ऐसे है, अच्छा ये कोड कैसे वर्क होता है. सो यू आर गोइंग मोर ऑफ अंडरस्टैंडिंग एग्जिस्टिंग कोड. यू आर नॉट गोइंग द डेटा स्ट्रक्चर और नॉट यू आर ट्राइंग टू बिल्ड द कोड. सो अगर आपको कोड डेवलपमेंट करना है, इंप्लीमेंटेशन करना है, रेडीमेड कोड को बाजू में रखो एंड यू कम अप विद दिस. लेट मी जस्ट टेल यू, मैंने जितना सारा डेटा स्ट्रक्चर पढ़ा है, यू आस्क मी सो विच इज द बेस्ट बुक फॉर डेटा स्ट्रक्चर. वैसे किसी ने पूछा नहीं, वैसे लोगों को आदत होती है, बट देन विच इज बेस्ट बुक फॉर डेटा स्ट्रक्चर. आई सेड आई हैव नेवर लर्न और रेड अ सिंगल बुक इन माई लाइफ फॉर द डेटा स्ट्रक्चर. I'm telling you truth. I never read any book for the data structure. I definitely have got 2-3 books at my home, but I never read the entire book. और ये book पढ़ा और वहां से मैंने प्रोग्रामिंग किया, आज तक ऐसा मैंने कभी नहीं किया. तो सर आपने कैसे किया? I draw the diagram, I come up with my own code. अगर सर गलत हुआ तो कंप्यूटर एरर दे ही देता है. अगेन आई गो बैक टू द पेपर, अगेन आई डेवलप द कोड. तो probably the code that I'm developing over here, you may not ask and do not ask, sir ये कौन से book से लिया गया है. Obviously, when there will be like some difficult algorithm or some definitions are there, so इसको क्या कहते हैं, उसको क्या कहते हैं, that is a place where you need a book for a data structure. आई रिपीट, सर नोड किसको कहते हैं, अब नोड किसको कहते हैं ये प्रोग्राम करके समझ में नहीं आएगा. हाँ दैट स्टफ यू कैन ऑलवेज रीड इट फ्रॉम अ बुक, दैट इज एब्सोल्युटली फाइन. या लिंक लिस्ट में ट्री में रूट किसको कहते हैं, यस यू कैन टॉक अबाउट. या फिर हाइट किसको कहते हैं, लेवल किसको कहते हैं. नाउ व्हेन दिस काइंड ऑफ टर्मिनोलॉजीज कम्स, फॉर द टर्मिनोलॉजीज, फॉर द concepts, you might need a book. When it comes down to the program, all you need is a paper, pencil, your computer, and your brain. I'm very sure you have got all four things, so you can be ready to learn data structure. ये मुझको एक्चुअली कल ही बताना चाहिए था, लेकिन कोई बात नहीं. I'm going ahead. and I'm starting once again from scratch. Please pay attention and do not ask me once again, sir ये trav is equal to null क्यों दिया और trav next is not equal to null क्यों दिया. Don't ask me. Do the paperwork for me if you want to understand it better. चलो go ahead. I'll start with. मुझको ये सारे नोड्स प्रिंट करने वन आफ्टर अनदर. सो मुझको प्रिंट क्या करना है, पहले तो मेरा आउटपुट क्लियर है. मुझको 11, 22, 33 आउटपुट का चाहिए. किसी भी एल्गोरिदम के लिए, किसी भी कोड के लिए यू फर्स्ट शुड नो कि आपको आउटपुट क्या चाहिए. So you look at the diagram, मेरे को आउटपुट चाहिए 11, 22, 33. You decided. अब from where you get the first one? Oh, first one that is very clear. A first one is nothing but the head pointer. So मुझको head से शुरुआत करना है, and then I want to print the data of each node. So how do I begin with the head? So to begin with the head, all we have, just a minute. Today is Thursday. 2 मिनट रुको. Am I audible? Okay. Let us continue further. So what I was saying is that you start with the first node. Yeah, I got the address of the first node. Now I want to print that node. How do I print that node? So first of all, you get the address of the first node. So I say, let's say 100 is the address of the first node. I got the address of the first node. What I want to print? I want to basically print Trav's data. Trav.data. So this part I want to print. At this moment, Trav is pointing to the first node and Trav.data. So I'm trying to print this data. चलो पहला node तो print हो गया. How do I go to the second node? How do I get the second node? How do I get the address of the second node? To get the address of the second node, a trav.data अगर 11 है, diagram देख के मेरे को पता चल रहा है, trav.next is nothing but 200, which is basically the address of the second node. If it is the address of the second node, how do I get it and how do I continue with this? So I simply say that take trav.next into trav. A trav.next is 200. So you get 200 into this. Now the trav is no more pointing to this. Now trav started pointing to this. Okay, is this good? Yes, this is good. You continue further. Now what you want to do? I want to repeat the process. A 11 is already printed. That is good. Let me again say printf trav.data. Again I'm printing the data. Or data is like 22. No problem. A 22 is printed. Again I want to go to the next node. Let's say 300. So 300 over here will be copied into the trav. And if 300 is copied into the trav, ultimately it is pointing to this. Okay, it is pointing to this. Now please tell, आपको repeat करना है process? Should I ये वापस से करना है? मतलब 11, 22 is printed. एक और iteration चाहिए इस loop का या नहीं चाहिए? Do you want one more iteration? Hello? अरे मैं पूछ रहा हूँ loop का iteration चाहिए क्या? The loop iteration is required. Have a look at this. अभी तक 33 is not yet printed. Please note 33 is not yet printed. As earlier Naneshwar was saying, or like some more few people are saying that कि sir वो जो 30 अगर आप लोग वो condition लिखते हो trav.next, right now you find that trav.next यहीं पर null हो रहा है. और अगर trav.next not equal to null, अगर मैं ये वाला condition लिखूंगा क्या हो जाएगा? The last node will never get printed. Please understand that. So what I'm saying, you continue further. I want one more iteration. So let me repeat this one more time. Let me print 33 over there. Let me go ahead and say that trav is equal to trav.next. Yeah, abhi trav.next क्या है? Abhi trav.next is null. So in this case, it will just point to 0. That's it. And now tell me, क्या ये loop फिर से एक बार रिपीट करना चाहिए? क्या ये लूप फिर से एक बार और एक इटरेशन करना चाहिए? नहीं करना चाहिए. क्यों? क्योंकि जो हमारा इनिशियल गोल था 11, 22, 33 प्रिंट करने का, वो गोल हमारा ऑलरेडी कंप्लीट हो चुका है, और अगर हमारा गोल कंप्लीट हुआ है, देयर इज नो पॉइंट इन रिपीटिंग इट वंस अगेन, एंड दैट इज द रीजन। तो मैं अभी कहां पर रुक रहा हूं? व्हेन आई एम स्टॉपिंग द लूप, आई एम स्टॉपिंग द लूप व्हेन माय ट्रैव इज बिकमिंग नल। सो you go ahead and you develop a condition, trav is not equal to null. I know that it is very stupid that एक simple से code के लिए we are spending half an hour, right? But still, because the same sort of conditions will come again and again and every time. So every time, please sit with that. You do the paperwork and then you come up with the condition. Do not by heart कि यहाँ पर ये condition होता है, यहाँ पर ये condition होता है. यहाँ पर मुझको क्या condition देना था? मुझको सारे नोड प्रिंट होने के बाद में रुकना था. सारे नोड प्रिंट हो गए, ये कैसे पता चलता? When I am reaching to the null. हाँ, कभी अगर आपको इन फ्यूचर आपको ऐसी जरूरत पड़ती है कि आई वांट टू गो टू द लास्ट नोड, I do not want to finish all the nodes, but I want to go to the last node. If you at all want to go to the last node, if you at all want to go to the last node, probably your condition will be trav dot next is not equal to null, because the last node कौन सा होता है? Last node वो होता है जिसके next में null होता है, correct? So जब आपको last node पे जाके रुकना है, at that time trav dot next is not equal to null. Trav not equal to null where you want to go through all the nodes. I hope this is clear to everyone. Really sorry, ये इतना stretch नहीं करना था, but still I do not want to stretch the same thing again and again. So it is worth you learn it once in a while, and then you write in a code. A while node is equal to trav, trav is equal to head. That is good, and then while a while trav is not equal to null, a trav is not equal to null, printf, a printf यहाँ पर printf नहीं है, यहाँ पर system dot println है. क्या फर्क पड़ता है? You want to print trav dot data and you want to go to the next node, trav is equal to trav dot next. That's it. Over. I just want to put one, let's say, list so that I can print it well. That's it, nothing else. I'm just showing that the data in a proper order. But by the way, at this moment, अभी तो मैंने एज्यूम किया था कि मेरा लिंक लिस्ट के अंदर 3 नोड है. व्हाट इफ अगर मेरी लिंक लिस्ट एम्प्टी होती तो? अगर मेरी लिंक लिस्ट एम्प्टी होती तो हेड के अंदर क्या होता? अगर मेरी लिंक लिस्ट एम्प्टी होती तो हेड के अंदर क्या होता? ओ, हेड के अंदर नल होता. और अगर हेड के अंदर नल होता तो फिर इन दिस केस क्या ये कोड वर्क होता? क्या ये कोड वर्क होता? चेक करते हैं, चेक करते हैं. नहीं वर्क होता मतलब, एक मिनट रुको जरा. वर्क होता मतलब क्या? Will it give a error? Not really give a error. It will print probably list. A node is equal to trav. A trav is equal to head. A trav is null in this case. Since trav is null over here, while trav is not equal to null. A while trav is not equal to null, condition is false. A trav is already null. पहले इसमें condition false हो गया, and then you come out of the loop. In short, in this particular case, if linked list is empty, nothing will be displayed. When linked list is empty, nothing will be displayed, and that is what right now you should be able to see in your linked list. Right click, run as Java application, and if I run it as Java application, let me take the input from the user saying that a choice is one, and what it shows? Oh, it shows me that my linked list is empty linked list. There is nothing to print in that linked list. Nothing to print in that linked list. That's it. Nothing much to do. This is all about my simple display function. Okay, now once my display function is there, I believe both time pass ho chuka hai. Now we will go ahead and we will start writing the rest of the functionalities one by one. If the display is clear, let us think of how do we create a new node and how do we add the node. तो सर कौन सा? अब अपने पास ऐड करने के प्रोबेबली 3 डिफरेंट ऑप्शंस हैं. एक तो वी वांट टू ऐड एट द बिगिनिंग, we might want to add at the end, we might want to add at the given position. So 3 possible options are there. So kaun sa padhenge? Let us learn all one by one. Let me begin with the function add last. What is add last? I want to create a new node, and the new node created, I want to put it at the end of the list. So how do we proceed with this? Again, always first draw the diagram. See the process? First draw the diagram, make yourself comfortable. अंडरस्टैंड ऑन पेपर कि आपको क्या क्या चेंज करना है और कैसे कैसे चेंज करना है. Once you understood that, then you think of how do you write it in a code. The very first step, I'm telling you the process. Okay. So very first step, what to do? Go ahead and you draw this. Very first step is obviously I want to create a node. I want to create a node. Definitely the node will have some address. A node will have some address, and then you will have some data there, and you might have null at the end. So that is very simple. ये जो नया node है, ये जो नया node है, this new node, we want to keep its address somewhere. Let's say that I'm keeping its address in a variable, let's say new node variable. So नया node है, you need to allocate the memory, you need to get it address. This will be obviously the first step. But after that, take a look at the diagram and tell me, जब मैं कहूंगा कि इस नोड को एट द एंड ऐड करना है, तो ये एड्रेस 400 मुझको कहां पर रखना चाहिए? Where that 400 should be kept? Where that 400 should be kept? हम लोग एड लास्ट की बात कर रहे हैं, एड लास्ट की बात कर रहे हैं. सो 33 का जो नोड है, जो लास्ट नोड है, जो लास्ट नोड है, उस लास्ट नोड के नेक्स्ट में if I keep it 400, then I can say that it is added at the end. Is this correct? Is this correct? Exactly. This is what I want to do. So finally पहले डायग्राम ड्रॉ करके ये समझो कि आपको करना क्या है. अब अगला क्वेश्चन ये है, so which node that you want to modify ultimately? Or the node that I want to modify over here is this part. इस जो लास्ट नोड है, ये जो लास्ट नोड है, इस नोड का नेक्स्ट. The question is, do you have pointer to that node? Do you have pointer to that node? I said, yes, I have got a pointer to this node, but not directly. The pointer to this node is kept in a previous of that. या इस नोड के नेक्स्ट में इसका पॉइंटर है. बट अगेन द क्वेश्चन इज, डू यू हैव एड्रेस ऑफ दिस नोड और नॉट रियली? आई हैव गॉट एड्रेस ऑफ दिस नोड इनडायरेक्टली इन एड्रेस ऑफ द प्रीवियस. व्हाट एग्जैक्टली इट मींस? व्हाट एग्जैक्टली इट मींस, अगर आपको ये मॉडिफाई करना है तो आपको इसका पॉइंटर चाहिए. बट द फर्स्ट क्वेश्चन इज दैट हाउ डू आई गेट द पॉइंटर टू दैट नोड? How do I get the pointer to that node? There is no option. You need to traverse all the way from the first node till the last node. I need to traverse from all the way from the first node till the last node. Please note, अब मुझको last node के आगे नहीं जाना है, मुझको last node के ऊपर जाना है. I want to go to the last node. By the which node you call it last node? Last node कौन सा होता है? Last node कौन सा होता है? अरे लास्ट नोड कौन सा होता है? लास्ट नोड वो होता है जिसका नेक्स्ट नल होता है. लास्ट नोड वो होता है जिसका नेक्स्ट नल होता है. प्लीज अंडरस्टैंड व्हाट यू आर सेइंग, राइट? एंड देन इफ यू अंडरस्टैंड दैट, so you understand the process very simple. So what are the steps? Steps are like this. Step number 1, create new node and initialize it. This should be like my first step. I understand that. What should be the second step? Traverse till last node. I'm not saying that traverse all the nodes. I'm going to traverse till last node. Traverse till last node. And then what is the last step? Add new node into next of last node. That's it. It is a 3-step process to be followed when you want to do add last. सर कोड कैसे लिखेंगे? हाँ, कोड कैसे लिखेंगे? दैट इज वेरी सिंपल. आई होप यू आर गेटिंग द पॉइंट. पहले डायग्राम ड्रॉ करो, समझो आपको क्या आउटपुट चाहिए. स्टेप नंबर 2, राइट इन अ प्लेन इंग्लिश व्हाट एग्जैक्टली यू आर ट्राइंग टू डू. एंड वंस यू अंडरस्टूड दैट, देन थिंक ऑफ इसको कोड में कैसे कन्वर्ट करेंगे, वन आफ्टर अनदर. लेट अस गेट स्टार्टेड. ए वेरी फर्स्ट थिंग, क्रिएट अ न्यू नोड एंड इनिशियलाइज इट. create a new node and initialize it. That should be very simple line. New node is equal to new node and whatever value that you want to initialize, probably 44 in our case in this diagram. So that value you pass it and you initialize the node. A constructor will take care of initialization. The first job is done. Second job, you want to traverse till the last node. How do I traverse till the last node? Already we spent a long time in traversing, so you understand it very well. So you start from the first node, you start from the first node, and all the way you want to go till the last node. So trav dot next is trav dot next is not equal to null. Simply say trav is equal to trav dot next. What happened? Yes, I go till the last node. So again, do the paperwork. Do not by heart that. Do the paperwork. Over here, you started with trav is equal to head. A trav is equal to head, so trav is equal to 100. क्या इसका नेक्स्ट नल है क्या? अरे इसका नेक्स्ट नल है क्या? इसका नेक्स्ट नल है? नहीं है. So you say trav is equal to trav dot next. So you go to the next node. You go to the next node. इसका नेक्स्ट नल है क्या? इसका नेक्स्ट नल है क्या? नहीं, इसका भी नेक्स्ट नल नहीं है. You go to the next node. And I guess initially you have seen that यहाँ पर 0 था. हाँ, in this particular case, do you see that इसका नेक्स्ट नल है क्या? इसका नेक्स्ट नल है क्या? Yes, obviously इसका नेक्स्ट नल है. So this is where I want to wait. This is where I want to do. Okay, I understood that. And now I got the pointer to this. I got the pointer to this. So I can say that trav is at this moment pointing to this. Oh, what is the last step? The last step is that add the node into the next. So आपका ये जो new node है 400, ये 400 ये जो एड्रेस है, ये एड्रेस आपको यहाँ पर राइट करना है trav के next में. So it is hardly a line of a code. Simply say that trav dot next is equal to new node. Trav dot next is equal to new node. That's it. Nothing else to be done. Let us just quickly go ahead. Let us just go ahead and try to type this much of code. Please note this code is not yet completed. This code is not yet completed, but at least this will give you a bit confidence. जो हम लोगों ने वहां पर लिखा है, यहाँ पर कैसे लिखेंगे? वैसे लिखेंगे. So you simply say that new node. Please note initialization. यहाँ पर हम लोग सिर्फ memory allocate कर रहे हैं. Initialization is taken care into the constructor. Initialization will be taken care into the constructor. You continue further. What is the first step? Create new node and initialize it. Next step, traverse till last node. How do you traverse till last node? You start with the first node. You start with the first node, and then all the way, while trav dot next is not equal to null, simply say trav is equal to trav dot next. This is done. And then what is the third step? And what is the third step? Add the node, add new node after trav, or other into, it's after trav in the sense simply saying that trav's next, right? So all you are writing is that trav dot next is equal to new node. So I'm saying that it is hardly simple code that we write. It is not number of lines that we write. The way we build the code, that is important. Chalo, we have built the code. What is the next job to be done? What is the next job to be done? So you say that, sir, go ahead and run it. No, never. Linked list में rule हमेशा याद रखना. First, you write a generic case. You ensure that this is correct. And now you start thinking of the special cases, special conditions. कि in which conditions your code might fail. You also call them as a corner cases or special cases. And you find that initially, this code is good. This code will work. No doubt on that. But the initial condition और स्पेशल कंडीशन जहां पर हमारी लिंक लिस्ट एम्प्टी होगी. Initially our linked list is empty. If our linked list is empty, please pay attention. If our linked list is empty, now what will happen? In this case, the head itself is null. Now think of it, will this code work correctly? Again, do not say directly no. Go do the paperwork. Do the paperwork and try to understand at which line this code may fail. अगर फेल होने वाला है तो कुछ करेंगे, अगर फेल नहीं होने वाला है तो then this code, if it is working, nothing to write specially, right? So you go ahead, you write the first line. A first line is that node new node is equal to new node. इसमें कोई प्रॉब्लम है क्या? So इसमें कोई प्रॉब्लम नहीं है. दूसरा, node trav is equal to head. A trav is equal to null. Null अगर आप लोग head में sorry trav में डाल रहे हो, null अगर हम लोग trav में डाल रहे हैं, is there any problem? No, there is still no problem. Problem कब होगा? प्रॉब्लम तब होगा जब मैं कह रहा हूं ट्रैव डॉट नेक्स्ट इज नॉट इक्वल टू नल. अरे प्रॉब्लम इज दैट you are trying to traverse till last node, but the linked list is empty. There is nothing in a list. If there is nothing in a list, you try to traverse, it is giving you the null pointer exception at this line. I'm very sure null pointer exception आप लोगों ने बहुत बार देखा है. अरे अगर आपने जावा पढ़ा है, नल पॉइंट एक्सेप्शन हमने बहुत बार देखा है, बहुत बार देखा है. ट्रस्ट मी, इवन दो यू आर 10 years experience in Java, this is the exception that you see the maximum time. So don't worry about it. So coming back to the point, I'm saying that in this case, चलो सर I understood कि ये कोड, एक मिनट, इससे मेरे को क्या समझ में आया, मुझको इससे ये समझ में आया ये वाला कोड इस स्पेशल केस में नहीं चलता. ओके, नहीं चलता. अब अगला क्वेश्चन, तो सर ऐसे केस में क्या होना चाहिए, व्हाट शुड बी डन इन दिस केस. इस केस में क्या होना चाहिए. अगेन, कंडीशन क्या चेक करना है मेरा क्वेश्चन नहीं है. मेरा कंडीशन ये मेरा क्वेश्चन नहीं है. मेरा क्वेश्चन ये है कि इस कंडीशन में करना क्या चाहिए, डायग्राम में क्या चेंज होना चाहिए. इफ दिस इज माय फर्स्ट नोड, लेट्स से 44 इटसेल्फ इज माय फर्स्ट नोड, तो ऐसे केस में क्या करना चाहिए, टेल मी इन इंग्लिश. डोंट ट्राई टू राइट अ कोड, यू ट्राई टू राइट अ कोड एंड देन यू पीपल मेक द मिस्टेक. आई एम सेइंग दैट सिंपल प्लेन इंग्लिश. माय क्वेश्चन इज दैट ऐसे केस में क्या करना चाहिए. ऐसे केस में ये जो नया नोड है, दैट इटसेल्फ इज योर फर्स्ट नोड. हेलो, एम आई करेक्ट. दिस नोड इटसेल्फ इज अ फर्स्ट नोड. एंड इफ यू आर सेइंग दैट इफ दिस नोड इज इटसेल्फ इज अ फर्स्ट नोड, व्हाट यू नीड टू डू इट डायग्रामेटिकली. डायग्रामेटिकली क्या होना चाहिए, ये मेरा न्यू नोड है जिसके अंदर एड्रेस है 400. डायग्रामेटिकली क्या होना चाहिए, nothing much. I need to just keep this address into the head so that this node becomes the first node. Is it very simple? That's it. मैं हमेशा ये कहता हूं कि पहले वो लोग डायग्राम में ठीक करो. लोग क्या कर रहे हैं, अभी आपने ऊपर भी बहुत सारे लोगों ने आंसर दिए थे, डायरेक्टली कोड लिखना चालू कर दिया था. और ट्रस्ट मी, जितने कोड लिखे थे मैंने पढ़े, सारे कोड जितने कोड लिखे थे उसमें से सारे के सारे कोड गलत थे. ऐसा क्यों होता है, सी यू पीपल अंडरस्टैंड लॉजिक, but you directly try to convert into the Java language or C language, so there are likely chances that you are making a mistake. I said that whatever you are understanding, first put it in diagram, then put it in English, and then put it in Java. If you go step by step process, trust me, it will be a easy job. अब बोलोगे सर इसमें बहुत टाइम जाएगा. हाँ, मेरे को पता है इसमें बहुत टाइम जाएगा, बट वैसे भी टाइम बचा के आपको जाना कहां पर है. आई होप द क्वेश्चन इज वेरी सिंपल. और जिंदगी में कभी ना कभी एक बार लिंक लिस्ट ठीक से पढ़ लेना चाहिए. अब आप लोग इतने सालों से जो अपने पढ़ना चाहिए था, लाइक आई एम वेरी श्योर आइडियली नाउ पीपल हु कम डाउन फॉर दिस ब्लॉक कोर्स, सीकेट एग्जाम में ऑलरेडी लिंक लिस्ट था, तो आइडियली आपने तभी पढ़ लेना चाहिए था. वी शुड नॉट हैव वेस्टेड अवर टाइम ओवर हियर. लेकिन वहां पर नहीं पढ़ा है, इसलिए अभी भी कंफ्यूज है. अभी भी कंफ्यूज है, अभी भी कंफ्यूज रहोगे, आगे जाके और कंफ्यूजन आएगा. कभी फिर कंपनी के कैंपस में जाओगे, वहां पर कंफ्यूजन रहेगा. सो यू नो, सम टाइम सूनर और लेटर एक बार जिंदगी में पढ़ लेना चाहिए. सर एक ही बार पढ़ना है, एक बार पढ़ना काफी हो जाता है, बट एक बार सही ढंग से पढ़ना चाहिए. नॉट बाय हाइटिंग द कोड और नॉट डायरेक्टली. मैं फिर से बता रहा हूं, देयर आर 3 स्टेप्स. जो कुछ भी आपको करना है, पहले डायग्राम ड्रॉ करो, उसको इंग्लिश में लिखो, और इंग्लिश में लिखने के बाद में फिर उसको कोड में कन्वर्ट करो. बाय द वे, इट इज स्पेशल केस. तो आपकी जो स्पेशल केस है, हाउ डू यू कंसिडर दिस स्पेशल केस. आई कंसिडर द स्पेशल केस समथिंग लाइक दिस. इफ head is equal to null, I understand that it is a linked list is empty. This is my special case, and in this special case all I need to do is that head is equal to new node. If this address I want to copy into this, nothing else I need to do it. Am I correct? Is this all right? Yes, head contains the address of a new node, nothing else is to be done. That easy. So you go back and you write it in a code. So obviously you want to always create the first node, no doubt on that. Now you check the special case. So I will call it, let's say, special case 1. And the special case 1, if list is empty, करना क्या है, make new node as first node of list. Make new node as a first node of a list. write in English. If you're written in English, then you go ahead, and then what you need to do, say if head is equal to null, you understand that your list is empty. If list is empty, what is to be done? Head is equal to new node. Okay, that is good. Else, what is else? Like a general case. And what is general case? The general case where you simply say that add a node at the end. But to add the node at the end, it is a two-step process. You need to first traverse till the last node, and you need to add the node over there. Oh, that's it. So is it done? This is absolutely done. And if it is absolutely done, you need to just call it from the main. So I guess वो आप लोग कर लोगे. So go ahead and we, yeah. चलो, I'm just going back. तो सर इसको कॉल कैसे करेंगे? गो अहेड, एड फर्स्ट, एड लास्ट, जो भी आपका केस है. सो लेट मी जस्ट टेक सम वैल्यू फ्रॉम द यूजर. And let me just ask user, what is that? Enter new element. Okay, done. Enter new element. Take the input. Value is equal to sc dot next int. You have taken it from the user. Simply say list dot add last. You pass that to the value, and you are done. It's my add last code. Run that code. Check it if it is working. Go ahead. हाँ, क्या क्या conditions है? पहले display. You find that my linked list is empty linked list. It is empty linked list. There is nothing in a linked list. Let me go ahead, add the node. कहाँ पर है? Add last. Let me add the node. Let's say 33. I added the node 33. Again, I'm saying display. This was my special case. My list is having only 33. You continue further. Again, you say that adding the last, let's say 22. 33 के बाद में मैंने 22 ऐड किया है. So please note, 33 के बाद में 22 ऐड किया है. Oh, this is working. And again you continue further. Again you say, let's say 11, and you find that display once again 33 के बाद में 22 के बाद में 11, and everything is working well. I hope you are getting the same results. Please check if it is going well for you. मैंने कोड ऑलरेडी कॉपी कर दिया है, और कोड ऑलरेडी आपके कोड शेयरिंग के ऊपर चल ही रहा होगा. जिसका कोड शेयरिंग के ऊपर नहीं चल रहा है, टेक इट फ्रॉम हेयर. What we are talking about was like, hey, we have like a special node, a special case. What is special case? If list is empty, whatever new node is created, that node, it should be a first node. So we simply say head is equal to new node. So there is nothing great into that. But if already there are few nodes in the list, what all I need to do? I need to first traverse till the last node. How do you traverse till the last node? You start with trav is equal to head, while trav dot next is not equal to null. Trav is equal to trav dot next. What this will do? This will take you all the way from first node till the last node. You are starting trav. ये पहले हम लोग यहाँ से हेड से शुरू कर रहे हैं, 100. इसका नेक्स्ट नल नहीं है. वी आर सेइंग trav is equal to trav dot next. इसका नेक्स्ट 300 है, इसका नेक्स्ट भी नल नहीं है. We say trav is equal to trav dot next. And initially you find that if this node was, इसका नेक्स्ट नल है, it only means that ये जो node है, it is the last node. Oh, I understand, this node is the last node. If this node is last node, अब क्या करना है? ये जो आप लोगों ने नया node create किया है, इसका जो एड्रेस है, this address I want to put it this address I want to put it over here, so that the last node, the already जो old last node होगा, that will start pointing to this. So how do I do that? ये मेरा trav है, ये trav का next है. So trav's next is equal to new node. Trav's next is equal to new node. That's it. I hope, Amit, that is fine. That is what last line is written over here. Else part ka end. Trav dot next is equal to new node. If this is done, we can go ahead and we can talk about the next function, add first function. Now you see that we took very long time to learn the first one. Yes, correct. Last node reference is equal to last node's next is equal to new node address. Absolutely correct. Display took a very long time. Add last took relatively less time. Let's see how it goes with the add first function. Add first function, and again the same technique we will follow once again. What is add first technique? We want to add a node at the beginning. You want to add a node at the beginning. A very first step that you should try. Or very first step, you first ask a question to yourself. You first ask the question to yourself कि क्या होना चाहिए, डायग्रामेटिकली क्या होना चाहिए. That should be like your very first question. चलो देखते हैं डायग्रामेटिकली क्या होना चाहिए. So डायग्रामेटिकली क्या होना चाहिए? डायग्रामेटिकली आपने एक नया नोड क्रिएट करना चाहिए. Oh yes, I need to create a new node. I need to create a new node. I need to initialize the node. Okay, that is good. I need to initialize the node. Whatever address is there, you can collect it in some pointer. Yeah, I collected a pointer, let's say 400. Okay, that is good. I have done that. What is the next step? What is the next step? Diagrammatically, again, please don't tell me the code. Please don't tell me the code. Look at the diagram and then what should happen? How you can say that this is the first node? Yes, people are saying that ultimately head should point to this node. But look at the diagram. Just by making head pointing to the first node, will it solve the problem? Look at the diagram. Head become 400. What will happen? If head become 400, then the linked list will have only the one node. A linked list will have only the one node. Okay, sorry, that is the problem. So what I should do? I should not first bother about this. First of all, I should say that अभी जो मेरा current first node है, अभी जो मेरा current first node है, क्या होना चाहिए? This one is 100. It should point to this. Am I correct? This should, जो नया node है उसके next में मेरा current head जो है 100 जो है वो पहले add होना चाहिए. That should be first step. And after you done that, then your next step should be the 400 pointing and head pointing to this. So definitely you need to do it as a two-step process. You need to do a two-step process, rather three-step process. Which three steps process? The step number one, you need to first allocate the node and initialize it. What is step number two? जो नया node का next है, it should point to your current head or the first node. उसका next current head को point करना चाहिए. और फिर तीसरा step है, head should point to the new node. Head should point to the new node. And let us just write it in English. ये diagram में क्या करना है वो मेरे को समझ में आ गया. Let me write it in English. First step, allocate and initialize new node. Step number one. What is step number two? Step number two, I'm saying it should be new node next should first node address. Okay, and third step, what we are saying? What is third step? The head should be new node. Head should point to the new node. That's it. And these are the three steps. Let us just go ahead, convert it into the Java language. Let us convert it to Java language. Allocate and initialize the new node. Okay, allocate and initialize the new node we are good at. A new node is equal to new node. We pass the value, constructor will take care of initialization. What is second? New node next should first node address. So you are saying that new nodes next, इसकी बात चल रही है यहाँ पर 100 आना चाहिए, ये काम चल रहा है. सो न्यू नोड नेक्स्ट इज इक्वल टू द फर्स्ट नोड एड्रेस. ए फर्स्ट नोड एड्रेस, यू ऑलरेडी नो दैट ए फर्स्ट नोड एड्रेस ऑलरेडी हेड में होगा. तो जो हेड में एड्रेस है, दैट एड्रेस यू कलेक्टेड ओवर देयर, दैट इज प्रोबब्ली योर सेकंड स्टेप. And third step, you are simply saying that head should point to the new node. A head should point to the new node. So new node address is let's say 400. So it should point to this. So new node का एड्रेस कहाँ पर है मेरे पास? और मेरे पास new node का एड्रेस है यहाँ पर, new node पॉइंटर के अंदर. So just go there and simply say head is equal to new node. So is 3 lines of code is sufficient? More than sufficient. Is 3 lines of code is sufficient? More than sufficient. Nothing else. माधुरी आप फिर से गलत लिख रहे हो. आपको माधुरी आपको हेड में क्या चाहिए? आपको हेड में क्या चाहिए? नए नोड का एड्रेस चाहिए. ड्रॉ द डायग्राम. यू सी दैट ए नए नोड का एड्रेस क्या है? 400. वेयर 400 इज? लुक एट द डायग्राम. वेयर 400 इज? ओ 400 इज इनटू द न्यू नोड. Where 400 is? A 400 is into the new node. So whatever address is there into the new node, whatever address is there into the new node, that address I want to copy into the head. I hope now it is clear. Not new node dot next. हेड के अंदर 400 आना चाहिए. ये 400 मुझको कहां पर मिल रहा है? न्यू नोड के अंदर मिल रहा है. न्यू नोड नेक्स्ट के अंदर नहीं मिल रहा है. न्यू नोड नेक्स्ट विल बी इनिशियली नल. इज दैट ओके? मैं फिर से एक बार डायग्राम ड्रॉ कर रहा हूं और हम लोग फिर से एक बार चेक करेंगे हाउ एग्जैक्टली इट शुड गो. मैं फिर से एक बार डायग्राम ड्रॉ कर रहा हूं. प्लीज पे अटेंशन. हाँ, ऑल राइट. आई एम गोइंग अहेड. आई एम गोइंग अहेड. व्हाट इज टू बी डन? व्हाट इज द वेरी फर्स्ट स्टेप? वेरी फर्स्ट स्टेप, एक कोड अभी आपके सामने लिखा हुआ है. वेरी फर्स्ट स्टेप, एलोकेट द नोड. एलोकेट द नोड. लेट्स से 400 some address 44, it is data available, and this address I'm taking in a pointer new node. This is like a node is allocated with the next. a by default उसका next null होगा. हमने कंस्ट्रक्टर में उसको null किया है, आप लोग चेक कर सकते हो. this is done. my first step is done. What is second step? The second step is that new node का next कहाँ पर point होना चाहिए? in new node का next हेड को मतलब पहले नोड को पॉइंट होना चाहिए. लेकिन वेयर इज द फर्स्ट नोड एड्रेस? ए फर्स्ट नोड एड्रेस इज 100 एंड दिस एड्रेस is already given into the head. So whatever the address inside head, the same address I need in a new node next. Whatever the address inside head, the same address I should take it over here. What will happen? This 100 that you are able to see it over here, it has to be copied into this. That is the second step. मैं एक एक line with diagram दिखा रहा हूँ. What is the third step? The third step is that अब this is pointing to this. इसमें कोई problem नहीं है. But linked list has to be always start from a first node, and head node should always contain the address of the first node. अब आपका पहला जो node था वो change हो गया है. You have got like a new node. So you simply say that head is equal to new node. Head is equal to new node. Now what will happen? Head is equal to new node. Now what will happen? This head, a new node का अंदर का एड्रेस कितना है? 400. This 400 address you are copying over here. So I'm saying this will start pointing to this. तो अब मेरी लिंक लिस्ट कैसे चलेगी? Have a look at this. अब मेरी लिंक लिस्ट हेड से शुरू होगी. From here it is going to this. It will print this. Then it is going to this. It will print this. Then it will going to this. It will print this. It will going to this. It will print this. उसके बाद में वैसे भी it is null. So you need to stop there. Is this clear? Good. And if this is clear, so again you can just go back and type it. But before that, sir, is there any special condition? Is there any special condition? Again, we will consider the case. Amit is asking the question, is it allowed to have sequence of node like 400, 100, 200, 300? Amit, these are just the addresses and these are just the example addresses. In real world, जब आप लोग programming करोगे, जब रियल वर्ल्ड आप लोग प्रोग्रामिंग करोगे, एड्रेसेस आपके हाथ में नहीं होते, एड्रेसेस आर गिवन बाय द जेवीएम एट रन टाइम, नाइदर यू कैन सी दोज एड्रेसेस। ये तो कुछ तो नंबर चाहिए ताकि हम लोग विजुअलाइज कर सके, तो इसके बाद में भी लोग कंफ्यूज होते हैं। अगर विजुअलाइज नहीं करोगे तो कितना हालत खराब हो जाएगा, यू कैन इमेजिन। एनीवे, if we have got like a head and initially head is equal to null, now tell me in this particular case क्या ये कोड चलेगा, क्या ये कोड चलेगा? लेट अस गो स्टेप बाय स्टेप, अपनी अकल नहीं लगाना। अगेन प्रणव वेट, प्रणव शैलजा वेट, कोड चलेगा नहीं चला अपनी अकल मत लगाना, गो अहेड डू इट, कोड करके देखो, डू द पेपर वर्क, और बाद में पेपर वर्क के बाद में सोचना कि कोड चलेगा या नहीं चलेगा। आई होप यू पीपल आर गेटिंग माय पॉइंट। आई एम जस्ट गोइंग अहेड। सो व्हाट इज द फर्स्ट स्टेप? व्हाट इज फर्स्ट स्टेप? allocate the node, allocate the node, so new node, एड्रेस कुछ भी हो सकता है, लेट्स से 400, लेट्स से 40, नेक्स्ट इज null and it is pointing, this is done. What is second step? What is second step? New nodes next is equal to head. ये चेक करो, ये new nodes next you are talking about this, ये क्या होना चाहिए? head. ये head क्या है? अभी null ही तो है, so this will be null only. अरे ये null ही रहेगा, इसमें कोई चेंज नहीं होगा, इसमें null ही रहेगा, इसमें कोई चेंज नहीं होगा, that is fine. What is the next step? The next step, you are saying head is equal to new node. Hey, what is the address in new node? Address in new node is 400, so this 400, it is pointing to this, it is pointing to this. Just tell me this is what should happen. अरे यही होना चाहिए, कुछ और भी होना चाहिए था। If your linked list is empty, यही होना चाहिए था। If यही होना चाहिए था, it only means that this code is working. इसलिए मैं कहता हूं कि रट्टा मत मारो। आई रिपीट वंस अगेन, रट्टा मत मारो, कि ऐसा कभी मत कहना कि सर ये कोड नहीं चलता है, डायग्राम ड्रॉ करो, नहीं चला फिर सोचना कि इसके ऊपर क्या करना चाहिए। लेकिन सर अगर वो कोड चल गया तो चल गया, तो रहने दो ना, व्हाई आर यू अननेसेसरी राइटिंग अ न्यू कोड? करेक्ट, गो अहेड, एट फर्स्ट create new node and initialize it. Okay, that is good. Now what is next step? Next step, what is that? Address new node next should point to head, the current first node, and then head should point to new node. If you continue further, you simply say that new node is equal to new node, you pass the value, the first step is done. Second step, what is that? New node dot next is equal to head. Okay, that is good. And a third one, head is equal to new node. This is done, over, finish, absolutely finish. So will it work? कॉल करके देखो। अब ये ज्यादा आसान है, एटलास जैसे कॉल किया था, कॉपी एंड पेस्ट, इंस्टेड ऑफ एटलास I just want to say it is add first. Instead of add last, I just want to say it is add first, and no other changes are really needed. So now will it work? Yes, ideally it should work. Why don't you try that? Let me just try to run this and let me check this if it is working. So initially there is nothing in a linked list. Let me try to add a node. Add first. Add first, I'm trying to add, let's say 30. ये मैंने 30 ऐड किया, एक और let's say add 20, मैंने 20 ऐड किया, you see मैंने कुछ गलत एंट्री किया क्या? सॉरी, फर्स्ट डिस्प्ले, हाँ सेकेंड, न्यू नोड, लेट्स से 20, and you see that a 20 is added before 30. Okay, that is good. 20 is added before 30. Again you say add first, again I'm saying 10, you find that 10 is added even before that. You see that there is absolutely no problem, even पहले नोड को भी कोई प्रॉब्लम नहीं आया. Let me simply go ahead. तो सर एडलास भी चलता है, चला के देखो. लेट्स से आई एम एडिंग 40 को मैंने एडलास किया, ये पहले मैंने 30 ऐड किया था, 30 के पहले 20 ऐड किया, 20 के पहले 10 ऐड किया, और बाद में एडलास्ट 40 किया है. एडलास्ट 40 किया है, यू चेक, ओ 40 is added at the end. Look like everything is working well. Check if it is working at your end as well. And if it is working at your end as well, we will take a break for 10 minutes. And after the break, we will talk about the rest of the functions. So please revise, do paperwork. Any questions are there, let me know. I hope you're there. Let us just get back to the code and what we have seen so far. A quick recap. A quick recap. What we are trying to write is a linked list. We are trying to write a linked list. To make a linked list, we say that linked list is list of nodes. It is a list of, it is a, the list of nodes, they are linked together. But to have a list of nodes linked together or list of items linked together, so we have written a kind of a linked list. But to represent each node, we have written a class called as a class node. What class node contains? Each node contains only two parts. One is the data and a pointer to the next node. It contains the data and a pointer to the next node. That's it. Nothing else it contains. And basic initialization job is done. Not anything apart from that. Making it as a static member class of it, advantage is I can directly access its private member in the outer class. Why it is made as a static member class? So that I can access its private members directly over here. अगर आप लोग वो नहीं करते, if it is not done as a static member class, what is the problem? हर बार आपको get next, set data, get data, this kind of code करना पड़ता. So I just thought that better I make it inside this. Otherwise इसके अंदर कुछ भी special नहीं है. The node class is like super simple class. All it is representing is one node. All it is representing is one node in a linked list where you have got some data and where you have got like a pointer to the next type, pointer to the next. Rather, this node next is a pointer of the same type. Next is a pointer of the same type. It is also, people call it as a self-referential class. This is a terminology. People call it a self-referential class. What is self-referential? A pointer, a class contains pointer of the same type. Pointer of the same type. Node class we have created, and then we went for like a head, because linked list you do not store the whole thing. You store only the address of the first node, and the first node will have address of the second. Second node will have address of a third, and third will have address of fourth. That's it. Initially, when you begin, the linked list is initially null, and you start with this. To display the linked list, the logic was you begin from the first node, until you traverse all the nodes. For each node, you print the data and then go to the next node. Print the data, go to the next node. Print the data, go to the next node. कब तक? जब तक आप लोग लास्ट नोड तक नहीं पहुंच जाते तब तक. So you talk about like a display method. Once it is done, you continue further. We have got the function, let's say add first. Add first, we are trying to add a new node at the beginning. To add a new node at the beginning, so you create a new node. वो जो नया नोड है उसके नेक्स्ट में आपका जो ओल्ड हेड होगा, जो करंट हेड होगा, उसको पॉइंट करवाओ, एंड देन यू सिंपली से हेड इज इक्वल टू न्यू नोड. दैट्स इट. So add first is done. And then what is add last? Now for add last, you see that if the linked list is empty at the moment, the first node itself is your new node. Otherwise, you can traverse till last node. And add new node address into that last node next. So only this much of code that we have written. Ekansh, I have done the whole revision for you, not only the node class. Right? I hope now it is comfortable for. And then we can go a step ahead. And then we say added position. So added position matlab kya? Added position matlab two things. First thing, I want to ask user that you enter a new element, and at the same time I want to ask user at which position you want to enter that. So enter element position. कि आपको कौन से पोजीशन पे वो एलिमेंट इंसर्ट करना है. So I'm taking two things from the user, and obviously now we have want to write a function add at position, and there will be two things. This value I want to put it at this position. So obviously I want to write a function list dot add at position. So let me write a function over there. And as we are written a function, there are two things. Which two things? Value and a position. तो लेट अस फर्स्ट अंडरस्टैंड ऑन पेपर कि एग्जैक्टली मुझको क्या करना है. ये वैल्यू इस पोजीशन के ऊपर ऐड करना है. तो पहले डायग्रामेटिकली क्या करना है, स्टेप नंबर 1. एंड वंस यू अंडरस्टैंड डायग्राम, देन द फर्दर स्टेप. चलो लेट अस गो अहेड. Let us go ahead. The very first thing, can you please tell me what should be the first step of adding a node at the given position? Suppose that this is like a positioning 1, 2, 3, 4, and I'm saying that the new node that I'm trying to create, I want to add at the position number 4. Obviously the very first step has to be first create a node. हाँ, जब तक आपका node ही create नहीं होगा तब तक add करने का सवाल ही पैदा नहीं होता. Oh, I understand that, and that's why I should first allocate a memory, and I need to, let's say 500, let's say 55, it's done. So this is a new node that you want to create. That is my step number 1. New node, let's say 500, done. What is next step? What is the next step? अब आपको क्या क्या modify करना है? Look at the diagram first, and first identify the areas which you want to modify. आपको क्या क्या change करना है इस diagram में? Take a look at this. आपको क्या क्या change करना है इस diagram में? अगर इस नोड को फोर्थ पोजीशन पे ऐड करना है तो चेंजेस क्या क्या होने चाहिए, कहाँ पर चेंज होने चाहिए. एक तो नया जो नोड है उस नए नोड का नेक्स्ट चेंज होना चाहिए. यू अंडरस्टैंड इट वेरी वेल. आई एम सेइंग दैट नाउ दिस नोड शुड पॉइंट टू दिस. ये होना चाहिए, ये पहली चीज. और दूसरी चीज, अगर आपको उसको फोर्थ पोजीशन पे डालना है, अगर आपको उसको फोर्थ पोजीशन पे डालना है तो थर्ड नोड जो है उसके नेक्स्ट में ये नया वाला नोड आना चाहिए. And if you do that, just check, will it be the correct linked list? Is it what the output that you look for? हाँ, yes. पहले ये कंफर्म करो कि आपको करना क्या है. इसका मतलब मुझको दो चीजें चेंज करनी है. एक कौन कौन सी दो चीजें चेंज करनी है? पहली चीज जो मुझको चेंज करनी है, इसका नेक्स्ट मुझको मॉडिफाई करना है, वेयर इट शुड बी लेट्स से 400. और इसका नेक्स्ट मुझको मॉडिफाई करना है, विच शुड बी द न्यू नोड एड्रेस, प्रोबेबली 500. It should be new node address, probably 500. This is what I need to do it. Chalo, if I understand this, let us go ahead and now think it more algorithmic way or programmatic way. तो दो चीजें अगर आपको मॉडिफाई करनी है, फर्स्ट ऑफ ऑल यू शुड बी हैविंग पॉइंटेड टू बोथ ऑफ देम. यू शुड बी हैविंग पॉइंटेड टू बोथ ऑफ देम. सो वेरी फर्स्ट थिंग, न्यू नोड का पॉइंटर तो मेरे पास होगा ही. व्हेन आई क्रिएट अ न्यू नोड, ऑब्वियसली आई विल बी हैविंग अ पॉइंटर टू द न्यू नोड. अब मुझको क्या चाहिए, अगर मुझे फोर्थ नोड पे ऐड करना है, देन आई नीड टू ऑल्सो गेट अ पॉइंटर टू द थर्ड नोड. हाउ डू आई गेट अ पॉइंटर टू द थर्ड नोड? So you start with this, you start with this. So you simply make that, you can take a pointer, let's say trav. You can say trav is equal to head, and then is it a third node? No, it is not a third node. Is it a third node? No, this is not a third node. So this is a third node. Yes, this is a third node. Somewhere you need to do the counting, and doing counting, you want to reach till the third node. You want to reach to the third node. So what is your step number 1? Step number 1 is allocate the new node and initialize it. Okay, good. What is step number 2? Step number 2 is traverse till position -1. Traverse till position -1. That is what you look for. That is second. And now tell me, एक आपके पास trav है, आपके पास new node है, अब आपको क्या करना है? What all things that you need to change? आपको दो पॉइंटर चेंज करने हैं. Which pointer I will change it first? Which pointer I should change it first? Which pointer I should change it first? Should I change new nodes next or travs next? Obviously, I should be first changing the new nodes next. I should be first changing the new nodes next. See the problem. अगर आपने गलती से, अगर आपने पहले इसको चेंज कर दिया, if you just make that, if you make this as 500 and if this start pointing to this, what will happen? आपका जो आपका next node होगा, this node will be lost permanently. This node will be lost permanently. फिर इसके next में डालने के लिए एड्रेस कहाँ से लाओगे? So always remember that ऑल आई नीड टू डू इज दैट, जो भी आपका पहला नया नोड है, नए नोड के अंदर जो एड्रेस आपको ऐड करना है, लेट्स से 400, इसको पहले ऐड कर लो, इसको पहले ऐड कर लो, एंड वंस यू एडेड दैट, देन यू गो बैक कि जो प्रीवियस नोड था इसको यहां पर ऐड कर दो 500, एंड देन यस माय लिंक लिस्ट विल बी कंप्लीटेड। सो मुझको दो स्टेप करने हैं, न्यू नोड के नेक्स्ट में 400 डालना है, ए न्यू नोड के नेक्स्ट में 400 डालना है, विच इज बाय डिफॉल्ट अवेलेबल इनटू द ट्रैव्स नेक्स्ट, इज द फर्स्ट स्टेप। और दूसरी चीज, ट्रैव के नेक्स्ट में 500 डालना है, विच इज अवेलेबल इनटू द न्यू नोड, which is available into the new node. Absolutely right. A simple terminology. तो सर ये कैसे याद रखेंगे? सर पहला कौन सा करना है, दूसरा कौन सा करना है? A very basic rule जो हमको इलेक्ट्रॉनिक्स में पढ़ाया जाता था। इलेक्ट्रॉनिक्स में बहुत सारे टाइप के स्विचेस होते हैं। अगर आई एम वेरी श्योर आप लोगों ने इतना इलेक्ट्रॉनिक्स फर्स्ट ईयर में पढ़ लिया होगा। एंड द टिपिकल a switch type, we call it as a make before break. What is make before break? You always first make the new connection before you break any existing connection. तो सर यहाँ पर क्या उससे लेने देना है? Have a look at this. A moment I say over here 500, अगर मैं यहाँ पर 500 कर रहा हूँ, प्लीज अंडरस्टैंड दैट आपका जो ओल्ड कनेक्शन था, ये कनेक्शन ब्रेक हो रहा है और ये एक नया कनेक्शन क्रिएट हो रहा है, ये नया कनेक्शन क्रिएट हो रहा है। सो आई एम सेइंग दैट यू आर ब्रेकिंग द ओल्ड कनेक्शन। आई ऑलवेज से दैट इट इज मेक बिफोर ब्रेक। मेक बिफोर ब्रेक का मतलब है पहले नए वाले कनेक्शन बनाओ, पहले नए वाले कनेक्शन बनाओ और उसके बाद में ओल्ड वाले कनेक्शन ब्रेक करो। दिस इज अ वेरी सिंपल रूल दैट यू कैन रिमेंबर थ्रू आउट द लिंक लिस्ट, थ्रू आउट द लिंक लिस्ट। सो जब भी ऐसे कंफ्यूजन हो, दो पॉइंटर चेंज करने हैं, जहां पर भी कंफ्यूजन हो दो पॉइंटर चेंज करने हैं, ऑलवेज इंश्योर दैट जो भी नया नोड होगा उसके पॉइंटर्स पहले सेटअप करो, नए नोड के पॉइंटर्स पहले सेटअप करो और उसके बाद में एग्जिस्टिंग नोड के पॉइंटर्स वापस से एक बार उनको ओवरराइट करो। दिस इज व्हाट ऑल यू कैन डू। इज द कंसेप्ट इज क्लियर? This is not only for this linked list, this is for throughout every linked list that we will be talking about. So don't forget that. And then I'm continuing further. Yes, it is a relay concept. तो सर क्या क्या करना है स्टेप्स? स्टेप क्या क्या करने हैं? स्टेप नंबर 1, what is that? Allocate and allocate and initialize new node. This is my first step. Okay, what is my second step? What should be my second step? The second step, traverse till position -1. I'm saying that using a trav pointer for that. Then next, what is the next step? The next step, अब मुझको दो पॉइंटर चेंज करने हैं. So I'm saying that new nodes next should point to travs next, right? You take a look at the diagram. New nodes next, अगर आप लोग ये इसको ट्रैव कह रहे हो, अगर आप इसको ट्रैव कर रहे हो तो ट्रैव का नेक्स्ट इज नथिंग बट 400. I'm saying that new nodes next should point to trav. New nodes next should point to the travs next. New nodes next should point to the travs next. Okay, I see that. And then last thing, यहाँ पर 500 आना चाहिए. So travs next should have address of the new node. You go back. Travs next should point to new node. Is it done? Yes, it is absolutely done. Now let us just go ahead, implement the basic stuff, and then we'll talk about special case, if any. So new node is equal to new node. You initialize that. Okay, I done initialization. Part 1 is done. Second part, how do I traverse till position -1? Hey, why don't you write a normal loop for I is equal to 1, I is less than position -1, I plus plus. Okay, that is good. Simply say trav is equal to travs next. Oh, that's it. Trav till trav is equal to travs next. So I have taken care. Obviously, initially I should have first said trav is equal to head. So you start with the first node and you go till position -1. This is done. Then you continue further. New nodes next. Make before break. तो पहले नया वाला लिंक बनाते हैं. न्यू नोड के नेक्स्ट में क्या आना चाहिए? ट्रैव का नेक्स्ट आना चाहिए. दैट्स इट. मैं फिर से एक बार रिपीट कर रहा हूं. न्यू नोड के नेक्स्ट में ट्रैव का नेक्स्ट क्यों आना चाहिए? अभी जो आपका ट्रैव है, अभी ट्रैव का नेक्स्ट 400 यहां पर पॉइंट कर रहा है, करेक्ट? सो न्यू नोड के नेक्स्ट में यहां पर जब 400 आएगा, यहां पर जब 400 आएगा, एट दैट टाइम यू कैन से दैट यस दिस इज पॉइंटिंग टू दिस। लेकिन यहां पर 400 आने के लिए ये 400 एड्रेस को कहां पर मिलने वाला है? ये 400 एड्रेस मुझको ट्रैव के नेक्स्ट में मिलने वाला है। तो जहां पर मिलने वाला है वहां से यहां पर ले रहे हैं, बाकी कुछ नहीं कर रहे हैं। मैंने ऑलरेडी इसको 4 बार रिपीट किया। Okay, go ahead. And the next one. Then you continue further. Trav.next is equal to new node. What is trav.next is equal to new node? अब यहाँ का 400 आपने ऑलरेडी यहाँ पर डाल दिया है, तो और कुछ करने की जरूरत नहीं है। ऑल आई नीड इज दैट यहाँ पर अब मुझको 500 एड्रेस चाहिए, सो दैट दिस विल स्टार्ट पॉइंटिंग टू दिस। बट यहाँ पर 500 एड्रेस कहाँ से आएगा? वो 500 एड्रेस इज नथिंग बट द एड्रेस इनसाइड न्यू नोड। I hope this is clear to everyone. And if this is clear to everyone, let us continue a step ahead. Let us continue a step ahead. By the way, is if you just do that, ये जो कुछ भी आप लोगों ने कोड में किया है, if you just follow that, ये फिर से एक बार, पहला स्टेप क्या था आपका? मैं और एक बार रिपीट कर रहा हूँ। कोड ये रहा। कोड शेयरिंग चल रहा होगा तो ज्यादा अच्छा होगा। You can just take a look at the code side by side. Step number 1, node new node is equal to new node. So what you are doing? You are allocating memory for the new node, and whatever is the address, you are taking the address into the new node pointer is the first step. So you got the address 500 over here. Then you are also initializing that. Okay, initialization is done in a constructor. We have taken care of it. What is second step? You want to traverse till position -1. So using this, ultimately you traverse till position -1. Position -1 कैसे? यहाँ पर initially you start with trav is equal to head, and then you just say that 1 2 3, आपको सिर्फ काउंटिंग ही तो करना है, ये आपको लास्ट नोड पे नहीं जाना है। You want to traverse till position -1, and that is the reason a simply written that for I is equal to 1, I is less than position -1, that is more than sufficient. To be frank, आपको 3 नोड ट्रैवर्स करने ही नहीं पड़ते, क्योंकि जो इसका इस नोड का जो एड्रेस है, प्लीज मेक अ नोट, इस नोड का जो एड्रेस है वो यहीं पर अवेलेबल है। डोंट फॉरगेट। So actually we are just traversing it twice, and that is more than sufficient to get the address of the third node. Just make a note of it. Okay, and then you continue further. New nodes next is equal to trav next. A new nodes next is equal to trav next. A trav next is looks like 400. So 400, that 400 I'm copying over here, it is pointing to this. That is my third line. And what is the last line? Last line is saying that trav.next is equal to new node. Trav.next, a new node kitna hai? 500. So 500 is copied over here. It is no more pointing to this, and this is my code. तो सर आपने पहले डायग्राम ड्रॉ किया, फिर कोड लिखा फिर से डायग्राम ड्रॉ किया। दैट वाज अ वेरिफिकेशन स्टेज कि जो हमने कोड लिखा है इज इट गोइंग करेक्ट, नॉट गोइंग करेक्ट, और सो ऑन। But sir, do you find any special case over here? Yes, there can be multiple special cases. We will talk about 1 or 2 cases from that. We will talk 1 or 2 special cases for that. बचे हुए cases, you can do it as your homework. The very first special case that I just bother about, there are 2 special cases I consider. If head is null, if the list is empty. Can you please tell me if list is empty? The special case 1, I'm saying that list is empty. अगर लिस्ट एम्प्टी होगी तो आपको क्या करना चाहिए? पहले लिंक लिस्ट आपकी है, डिसीजन आपको लेना है कि पहले क्या करना चाहिए, उसका डिसीजन आप लोग ले लो, उसके हिसाब से कोड हम लोग लिखेंगे बाद में। माय क्वेश्चन इज दैट ये जो कुछ भी आप लोगों ने नया नोड क्रिएट किया है, इसका करना क्या है? इफ एट ऑल लिस्ट इज एम्प्टी, व्हाट आई शुड डू? What should I do? You tell me what is to be done. All I need to do is that I need to make that particular node as a first node. Okay, if you are saying that that particular node you want to make it first node, so वापस एक बार, तो सर हमेशा ऐसे होता है क्या? नहीं, लिंक लिस्ट आपकी है। जब लिंक लिस्ट आपकी है, डिसीजन आपको लेना है। When you are going to make your own linked list, it is your decision what exactly you want to do. So you just said that if list is empty, make node as first node. तो सर उसमें एग्जिस्टिंग कोड नहीं चलेगा क्या? सवाल ही पैदा नहीं होता एग्जिस्टिंग कोड चलने का, क्योंकि आप लोग यहाँ पर क्या कर रहे हो? यू आर ट्रैवर्सिंग टिल पोजीशन -1। अगर अगर आपकी लिंक लिस्ट एम्प्टी होगी, हाउ यू कैन ट्रैवर्स टिल पोजीशन -1? इट विल नॉट बी जस्ट पॉसिबल। It will not be just possible, and that code is going to fail. Yeah, I understand. Case number one. Case number one is very simple, where I consider that list is empty. Let me talk about the second special case. Please pay attention. Special case number two. Special case number two, where add at first position. Add at first position. That is, I'm simply saying that position is equal to 1. I believe that this is another special case. This is another special case. Isn't it? Isn't it? Again, जो logic आप लोगों ने लिखा है, logic, hello, logic, you are saying that traverse till position -1. But अगर आपको पहले नोड पे लग जाना है, तो you want to traverse till head. Oh, but problem is that how do I traverse till head? There is no code available. Please note that ये जो दोनों स्पेशल केसेस थे, ये जो दोनों स्पेशल केसेस थे, इन दोनों स्पेशल केसेस में आपको हेड मॉडिफाई करना पड़ता. अगर दोनों स्पेशल केसेस थे तो हमको हेड मॉडिफाई करना पड़ता. अगर आप लोगों ने ठीक से आपका कोड चेक किया है, इस कोड में कहीं पर भी हेड के चेंज का कोड ही नहीं है. इट इज वेरी क्लियर कि इन बोथ ऑफ दी स्पेशल केसेस कोड इज नॉट गोइंग टू वर्क. तो सर और भी कोई स्पेशल केस होगी? वैसे टू बी फ्रैंक स्पेशल केस और भी हो सकती है. देयर कुड बी वन मोर स्पेशल केस. वन मोर स्पेशल केस. One more special case, you can simply say that special case number 3, add node, add node beyond position. A beyond position मतलब आपके पास टोटल 5 नोड्स हैं. A beyond position मतलब आपके पास टोटल 5 नोड है. Someone is saying that add at position number 6, add at position number 7, add at position number 8. अगर 5 ही नोड है तो पोजीशन नंबर 6 या 7 या 8 के ऊपर ऐड हो ही नहीं सकता. Again, what should be done in that case? What should be done in that case? Again, linked list आपकी है, choice आपका है. Linked list आपकी है, choice आपका है. You may say that we will throw the exception. If you say that you should throw the exception, go ahead, throw the exception. Someone says that नहीं sir, I don't want to give an exception. अगर अगर यूजर गलती कर रहा है, invalid position दे रहा है, still I want to add the node at the end. Choice is yours. So कौन सा better है? आपकी linked list है, आप decide करो. So few people might say that, sir, I want to throw the exception, write the code for that. Few people might say that, nahi sir, I want to add it at the end, write the code for that. Choice is yours. I repeat once again. तो सर लिंक लिस्ट में कौन सा सही होता है? लिंक लिस्ट में सही या गलत कुछ नहीं होता. जब डेटा स्ट्रक्चर आपका होता है तो आप लोगों ने आपके रिक्वायरमेंट के हिसाब से कोड लिखना चाहिए. और इसीलिए मैं कहता हूं यू शुड नॉट फॉलो द बुक्स. वो बुक में जाते हैं, बुक में जाके कोड रखते हैं और फिर वहां पर आके लिखते हैं और कहते हैं कि नहीं नहीं लिंक लिस्ट ऐसा ही होता है. लिंक लिस्ट ऐसा ही नहीं होता है, आपकी रिक्वायरमेंट के ऊपर डिपेंड होता है. यू मेक योर ओन रिक्वायरमेंट एंड देन यू इंप्लीमेंट योर ओन कोड. दैट इज अ लॉजिक. तो चलो हम लोग जाते हैं. अब मैं मेरे पहले दो केसेस का तो मेरे को क्लियर है. जो पहले दो केसेस का क्लियर है, लेट मी इंप्लीमेंट दैट. सो स्पेशल केस वन. स्पेशल केस वन, व्हाट इज दैट? If list is empty, add node at the start. Okay, that is good. Special case number 2. The special case number 2, if position is equal to 1 or I say that less than 1, then again add node at the start. In both cases, तो सर दोनों में एक ही लॉजिक लिखना है, एक ही लॉजिक लिखना है. तो सर वापस से हेड इज इक्वल टू न्यू नोड करेंगे क्या? कर सकते हैं, बट आई पर्सनली बिलीव दैट इंस्टेड ऑफ rewriting the code, why don't we call the ready-made function? If we already have got a function, so if head is equal to null, or if position is less than or equal to 1, let me just make a call to the existing function instead of writing a new one. Otherwise, else you can think of going like a general case, add node at given position. Add node at given position like a else part, and into the else part I can write this logic. So will it work? Yes, that is more than sufficient. So special case number 3, I'm not doing that. I'm leaving it for you people if you are interested in. जिसको इंटरेस्ट होगा वो लोग करो. So you go ahead. एक कोड ऑलरेडी हम लोगों ने यहाँ पर लिख दिया है. So nothing much to be done. Let me just run the program. Let me run a program. Run. Let's say 3, 10, 3, 20, 3, 30, 3, 40. Hey, what is your current linked list? Oh, current linked list is 10, 20, 30, 40. Okay, that is good. Let me add the node at the given position. Position number, choice number 4. New node is, let's say, 50. At the position number, at the position number 4, at the position number 4, let me add it over there. And then ये मतलब 10, 20, 30 के बाद में ऐड होना चाहिए. 10, 30, 10, 20, 30 के बाद में 10, 20, 30 के बाद में 50 ऐड होना चाहिए. That is in front of you. It is working well. So और कुछ करना है और कुछ भी नहीं करना है. That's it. You continue further. You continue further. Let's say that what if you give the position? What if you give the position is equal to 1? So position is equal to 1. So you are trying to add the element at the beginning. Okay, let's say 60. I'm trying to add. Sorry, मैंने उल्टा किया. I written a element is equal to 1. Position is equal to 60. You find that if I'm trying to write a position is equal to 60, definitely it is not working. So वो last वाला केस वैसे भी मैंने कंसिडर नहीं किया था. कोई बात नहीं है, फिर से एक बार ट्राई करते हैं. एड फर्स्ट वाला मैं काम करता हूँ, यही से शुरुआत करता हूँ. एडेड पोजीशन, ए एडेड पोजीशन. अभी मेरा लिंक लिस्ट एम्प्टी है. मेरा लिंक लिस्ट एम्प्टी है. आई एम सेइंग दैट आई एम एडिंग 10. आई एम एडिंग 10 एट द फर्स्ट पोजीशन. इज इट वर्किंग? ओ, इट इज वर्किंग. तो मेरा जो पहला स्पेशल केस था, हेड इज इक्वल टू null, that has been handled. Okay, you continue further. You try to add another new element, let's say 20 at position number 2. Oh yes, it is getting added at position number 2. आप लोग चेक कर सकते हो. Yes, 10 के बाद में 20 ऐड हो रहा है. So adding at the last position there is not a problem, but adding a position beyond that. अब मेरी लिंक लिस्ट में सिर्फ 2 नोड है, लिंक लिस्ट में सिर्फ 2 नोड है, और आप लोग कह रहे हो add what that add the element 30 at position 10. 2 नोड में अगर आप लोग 10th पोजीशन पे जाओगे, दिस इज गोइंग टू थ्रो द एक्सेप्शन. सो आपको दिख रहा है. ऑब्वियसली अगर हैंडल करना है तो आपको इस लूप में चेक करना चाहिए. अगर हैंडल करना है तो शायद आपको लूप में चेक करना चाहिए. चलो तो चलो वो भी मैं लिख ही देता हूँ. आपके लिए होमवर्क देने से अच्छा है, बेटर आई राइट इट. आई राइट इट देयर इटसेल्फ, सेइंग दैट इफ trav dot next is equal to null, I just simply say break. What I'm saying, special case number 3. Special case number 3, if position is beyond the length of list, then add node at the end. मेरी लिंक लिस्ट है तो मैंने कहा if at all I'm finding it next is equal to null, so मैं वहीं पर रुक रहा हूं, and obviously I'm trying to add a node after that. चलो, I hope you people have tried it. Go ahead and let me know if it is working for you. चलो, good. So if it is going well, तो सर अभी आपने जो कोड मॉडिफाई किया है इसकी वजह से एक्सेप्शन नहीं आएगा क्या? आइडियली तो नहीं आना चाहिए. सो यू कैन ऑलवेज गो देयर एंड यू कैन ट्राई दैट एज वेल. जब तक आप लोग रन कर रहे हो तब तक मैं एक बार और क्विकली चेक कर रहा हूँ. सो 3, 10, 3, 20, 3, 30. 10, 20, 30, this is my linked list, and I'm saying that add at position, let's say 40, and 40 I'm giving a position 10. Obviously 3 नोड का लिंक लिस्ट है, मैं पोजीशन 10 दे रहा हूं, but it is not giving me the exception. But then where the node is added, in my case the node is added at the end. The kind of code that I have written is following that. All right. So what we have done is all this. Now let us continue further. Let us continue further. What if you want to delete a element at the first position? If you want to delete an element at the first position, what all efforts that you want to take? Take a look at this. And can you please tell me diagrammatically? I hope these steps will be easier क्योंकि यहाँ पर ज़्यादा कुछ करने लायक नहीं है. Take a look at this. What if you want to delete a node at the first position? Take a look at the diagram and tell me एक पहला नोड अगर नोड मुझने डिलीट कर दिया, ये नोड अगर मुझको डिलीट करना है तो क्या होना चाहिए एज पर द डायग्राम? एज पर द डायग्राम क्या होना चाहिए? मैं आउटपुट नहीं पूछ रहा हूं, मैं कोड भी नहीं पूछ रहा हूं. प्लीज टेल मी इन इंग्लिश क्या करना चाहिए. Absolutely, in this particular case, head should start pointing to the next node. That's it. And if head is pointing to the next node, हम लोग जावा में हैं, you know it very well, this node will be then automatically garbage collected. If no one is going to refer that, by default this node will be garbage collected. So मुझको और कुछ करने की जरूरत नहीं है. अगर हम लोग C++ में होते हैं तो हमें जाके फ्री करना पड़ता है या डिलीट करना पड़ता है मैन्युअली. गुड थिंग अबाउट जावा इज दैट मुझको इसमें कुछ भी एफर्ट्स लेने की जरूरत नहीं है. ऑल आई नीड टू डू इज दैट जस्ट पॉइंट इट टू द नेक्स्ट नोड. दैट्स इट. और कुछ करने की जरूरत है? और कुछ भी करने की जरूरत नहीं है. हाँ बट रुको, इज देयर एनी स्पेशल कंडीशन टू बी कंसिडर्ड फॉर दिस? is any special condition to be considered for this? What is special condition? ये head is equal to head dot next हम लोग तब कर सकते हैं जब हमारी लिंक लिस्ट empty नहीं हो. If linked list is empty and you write head is equal to head dot next, what will happen? In this case, what will happen? It will give me the null pointer exception. Oh, sorry, I don't want a null pointer exception. So I need to always check if the list is empty. If the list is empty, then do not try to delete. If list is not empty, then and only then I want to delete the first node. I want to delete the first node. That's it. तो सर एक बात बताओ, if list is empty क्या करना है आपको? स्पेशल केस में आपको करना क्या है ये तो बताओ. अगेन योर रिक्वायरमेंट क्या है? लिस्ट एम्प्टी. If list is empty, in case of del first, what output that you are looking for? क्या करना चाहिए आपने? If list is empty and user is saying that delete that, अरे deletion चल रहा है कोड. अमित, we are into the function delete first function. So choices क्या क्या है? एक choice है ignore that. एक choice है ignore that. And choice number 2, throw the exception. Throw the exception. Choice is yours. या तो ignore करना है या तो exception देना है. It is up to you. So you may say that throw exception. If list is empty, you might want to throw the exception. Choice is yours. Okay, let us just go ahead and write a code. यहाँ पर वैसे कोड में लिखने लायक ज्यादा कुछ नहीं करना है. ये आपको सिर्फ क्या करना है, ये जो 100 है इस 100 के जगह पे आपको 200 करना है. ए where do you get 200? A 200 is already there in old heads next. 200 you already get into the old heads next. Simply write a line of code. Head is equal to head dot next, so that this will start pointing to this. I repeat, इस नोड का मुझको कुछ भी नहीं करना है. क्यों? क्योंकि वो नोड when no one is referring that node, Java JVM will automatically garbage collect that. JVM will automatically garbage collect that. So hardly 2-3 lines of code we need to write it as far as del first is concerned. कहां पर गया? एड फर्स्ट हो गया, एड लास्ट हो गया, एडेड गिवन पोजीशन हो गया. लेट मी कंटिन्यू फर्दर. पब्लिक void del first and del first, what I want to say, if special case 1, if list is empty, throw exception. Okay, throw exception. And then general case, what is that? Make head pointing to next node. Done. So it's the 2 lines of code. First line of code, if head is equal to null, simply you can say throw new exception. Throw new exception, runtime exception, you can say that, whatever you want to write it. list is empty. I just written that message and I just left it. And the second one, in general, what I want to do it is hardly one line of stuff. Head is equal to head dot next. Please note that the old, what is that? The old first node will be garbage collected since no one is pointing to that. So call करने के लिए कोई efforts लेने हैं? Not absolutely. A Delphus का केस कौन सा था? Case number 5. Go to the case number 5. Simply make a call list.del first and your first node is deleted. So will it throw the exception? Yes, it may throw the exception. If you're worried about it may throw the exception, go ahead, make a try catch block. And if at all there is an exception, just print that exception. That's it. All we can do. E dot, I'll say get message. All right, I'm done with this. So will this code work? I believe so. You can always try it at your end. Check if it is working. Let me go ahead. Let me run. ये पहले तो लिंक लिस्ट क्रिएट करते हैं. So 3, 10, 3, 20, 3, 30. Display. Oh, 10, 20, 30 is there. It is available. Let me say del first. 5. पहला नोड शायद डिलीट हो गया. You check. Oh, 10 is gone. Again 5. Again display. 20 is gone. 5. Again. Now there is nothing. 30 is also gone. So पहला भी डिलीट हो गया, दूसरा भी डिलीट हो गया, तीसरा भी डिलीट हो गया. सर अब क्या होगा? If I try to delete once more, अब क्या होगा? अभी आपका लिंक लिस्ट एम्प्टी बन चुका है. In this case, what will happen? At this time, it will throw the exception saying that list is empty and that exception I have printed over here. All right. Please check. Is it going well? I hope it was very simple. Let us continue further. Let us continue further. And to continue further, I want to delete a node at a given position. और एक काम करते हैं, पहले उससे सिंपल वाला है कि जो है वो लिख लेते हैं. Let's add, I want to delete all the nodes. How do you delete all the nodes? How I can delete all the nodes? Yes, Java में बहुत ही simple है. So in Java, all we need to do is that we need to just make the entire list eligible for the garbage collection. And just to make the entire list eligible for the garbage collection, all I am doing is that simply make head is equal to null. And moment you make head is equal to null, I say that all nodes will be garbage collected. वापस से जिन लोगों ने कभी C++ में डेटा स्ट्रक्चर किया होगा उन लोगों को पता है इतना आसान नहीं होता है. वहां पर यू नीड टू टेक एफर्ट्स, यू नीड टू राइट अ लूप. एक एक डेल फर्स्ट लूप में बार बार करना पड़ता है. लेकिन हम लोग जावा में, लेट अस टेक एडवांटेज ऑफ जावा, एंड जावा सेज दैट जस्ट मेक हेड इज इक्वल टू नल. सो आपका पहला नोड ही रेफर नहीं होगा, वो गार्बेज कलेक्ट हो जाएगा. ऑब्वियसली उसके आगे वाला भी गार्बेज कलेक्ट हो जाएगा, ऑब्वियसली उसके आगे वाला भी गार्बेज कलेक्ट हो जाएगा. सो ऑल दोस नोड्स विल बी डिलीटेड. दैट्स इट. सो सर एक आध क्विक एग्जांपल, क्विक चेक हो जाए, और क्विक चेक हो जाए कोई बात नहीं. लेट्स से 3, 10, 3, 20, 3, 30. You see, oh, 10, 20, 30, 3 nodes are there. 3 nodes are there. You just go ahead, say 8, delete all. 8, delete all, and now find that my list is empty. Nothing to be done. Oh, why don't you try it? हार्डली एक लाइन का कोड लिखना है, तो मैं कोड इसके लिए शेयर नहीं करने वाला अलग से. हार्डली वन लाइन ऑफ कोड टू बी रिटर्न. आई गेस अगर आप लोगों ने जावा कलेक्शन फ्रेमवर्क किया है, जावा कलेक्शन फ्रेमवर्क में इसके लिए कौन सा फंक्शन है? समवन रिकॉल? जावा कलेक्शन फ्रेमवर्क में सारे नोड डिलीट करने के लिए कौन सा फंक्शन है? समवन रिकॉल? ऐसा कोई फंक्शन नहीं है. इज इट रियली द फंक्शन रिमूव ऑल नेम? Not even remove. Remove and remove all. Remove is for the removing at a given index. There is a function by the name clear. Go and check Java collection framework. Collection interface में check करना. Yes, Prathamesh, you are correct. So it's like a clear function. Clear function will clear everything. आप लोग चेक कर सकते हो, जावा डॉक्स आपके पास होंगे, ओपन करके देख सकते हो. आपका जो कलेक्शन इंटरफेस है उसके अंदर क्लियर नाम का मेथड अवेलेबल है. Okay, that is good. That is good. And then I want to continue further. I want to delete. आज का लास्ट फंक्शन हम लोग देखेंगे और उसके बाद में हम लोग रुकेंगे. Last function, I want to delete at a given position. So I want to give the position to the user and I simply say delete at that position. I want to delete at that position. Let us just go ahead and I want to delete at that position. So how do I delete at that position? Let us go back and say that I want to delete a node at the second position. I want to delete the node at the second position. This node to be deleted. ये क्या करना पड़ेगा? टेक अ लुक एट द डायग्राम एंड टेल मी क्या करना पड़ेगा. फाइनली क्या होना चाहिए? अगर मुझको ये वाला नोड डिलीट करना है तो फाइनली क्या होना चाहिए? व्हाट शुड हैपन? अगर मुझको ये वाला नोड डिलीट करना है तो फाइनली क्या होना चाहिए? इंग्लिश में बताना, कोड में मत बताना. यस तेजस, यू आर करेक्ट. आइडियली यहां पर 300 आना चाहिए सो दैट दिस विल स्टार्ट पॉइंटिंग टू द नेक्स्ट नोड. अगर आपको इफ यू वांट टू डिलीट द नोड एट द सेकंड पोजीशन, सिंपल लैंग्वेज, फर्स्ट पोजीशन के नोड के नेक्स्ट में थर्ड पोजीशन के नोड का एड्रेस होना चाहिए, राइट? सो इसके नेक्स्ट में अभी जो 200 है वो 200 नहीं होना चाहिए, इसके नेक्स्ट में 300 होना चाहिए सो दैट द नोड of the second position will get deleted. Okay, that is good. But the question is, how do I implement this? The question is, how do I implement it? Obviously, I can say, listen carefully. मैं एक थोड़ा सा अलग तरीका बता रहा हूँ जो यूजुअली मैं नहीं बताता. So it's like a different way I'm trying to tell you. So what is the different way? All I'm saying is that you traverse, listen carefully, you traverse till position. You traverse till position. अगर आपको सेकेंड नोड डिलीट करना है, please traverse up to the second node. Now what is the problem? The problem is that if you traverse till the second node, will it solve your problem? If you traverse till the second node, will it solve your problem? The problem is that आपको सेकेंड नोड तक ट्रैवर्स करोगे, आपको सेकेंड नोड को मॉडिफाई नहीं करना है. सेकेंड नोड के जो पहले वाला नोड है आपको उसको मॉडिफाई करना है. सो व्हाट आई एम सेइंग इज दैट उसके पहले वाला जो नोड है मुझको ये मॉडिफाई करना है. सो इफ एट ऑल आई एम गोइंग टू द नेक्स्ट नोड, going to the node to be deleted, it is of no use. I actually need a node before that. I actually need a node before that. I hope I'm audible. Good. Okay. हाँ fine. So I'm continuing further. What I'm saying is that तो सर ये शायद इतने छोटे एग्जांपल में आपको समझ में नहीं आएगा. So I'll take a bit bigger example. Suppose I'm drawing a simple linked list now. This like is a head node. Head is pointing to let's say 11. This is pointing to 22. This is pointing to 33. This is pointing to let's say 44. This is pointing to let's say 55, and this is pointing to null. What I want to do is that I want to delete this node. I'm interested in deleting this node. If I want to delete this node, I can always write a code. I can always write a code to traverse till the position. This node, let me traverse position 1, 2, 3, 4. I traverse till the position number 4. But what I'm saying, if I traverse till this position, this is of no use to me. This is of no use to me because actually जो modify करना है, modify इसको नहीं करना है. Modify किसको करना है? जो उसके पहले वाला node है उसको modify करना है. That is actual our requirement. That is actual our requirement. तो सर एक काम कर सकते हैं, we can traverse till position -1. I know that we can traverse till position -1, but instead of that, I'm just trying to look for some different trick. The trick that probably help you, the trick that probably help you while learning trees. तो पोजीशन -1 से ट्रैवर्स करके आप लोग कर ही सकते हो, आई नो दैट, बट आई एम टेलिंग यू वन मोर ट्रिक. See, the trick is something like this. Trick is something like this. We will have two pointers. One is a trav pointer. See it carefully. One is a trav pointer, and another is, let's say, temp pointer. There are two pointers. One is a trav pointer, and another pointer, I can say temp pointer. What I want the temp pointer to be move before trav pointer. तो सर ये कैसे होगा? आई एम सेइंग पहले temp को यहां पर लेके आओ, and then take trav to the next. Again continue, temp को यहां पर लेके आओ, take trav to the next. Again temp को यहां पर लेके आओ, and then take trav to the next. What I will ensure is that when trav is pointing to this node, temp is pointing before that node. And if temp is pointing this before this node, what all I need, I simply need that ये जो temp है, ये जो temp है, इसके next में ये जो trav है, इसके next का address जाना चाहिए. Do you visualize this? Yes, absolutely correct, Poonam. Temp के next में trav के next का address जाना चाहिए. Don't worry, मैं repeat करता हूँ वापस एक बार. मैं फिर से एक बार repeat कर रहा हूँ. What I'm saying is that instead of having two pointers, I will use, instead of using one pointer, I will use two pointers. I will use two pointers. This is a pointer that I want to traverse. A trav is equal to head से शुरू करेंगे. Trav is equal to head से शुरू करेंगे. But this pointer, I'm saying, is the previous pointer, or let's say temp pointer. Now every time I'm saying that trav is equal to trav or next. Every time I'm saying that trav is equal to trav dot next, before trav going to the next node, I say temp is equal to trav, and then trav is equal to trav's next. Again you continue further, temp is equal to trav, and then trav is equal to trav's next. Again temp is equal to trav, and trav is equal to trav's next. What this will give me, by the time trav reach to the position, by the time trav reach to the position, the temp is going one line behind it. Oh, temp is going one line behind it. Now what I need to do? All I need to do is that whatever is the address, whatever is the address into this node, whatever is the address, temp के next में जो भी pointer है, जो भी address है, that I want to put it into the temp's next. That I want to put it into the temp's next. That's it. This is my temp. This was my trav, and it is done. It is hardly a simple logic that we are writing. Why not you go there and try to implement a basic case? A basic case logic क्या है? I'm saying that I am trying to traverse with two pointers, but I'll write it step by step. So your step number one, traverse till position using trav, correct? But at the same time, take temp pointer traversing behind trav pointer, right? So how do we implement it? Let us just go ahead and simply say node temp is equal to null. Initially temp is equal to null and trav is equal to head. यहाँ तो कोई प्रॉब्लम नहीं आना चाहिए. I'm saying for you want to traverse till the position I is equal to 1, I is less than position. अब मैं less than -1 नहीं लिख रहा हूँ. I'm saying that I is less than position and I plus plus. What I want to do? I want to simply say trav is equal to trav's next. But I want to maintain a pointer which is traversing behind temp pointer, which is running behind a trav. I'll keep it simple word, running behind trav. Okay, so every time I'm going to the next node, first say temp is equal to trav, and then say trav is equal to trav's next. First say temp is equal to trav, and then say trav is equal to trav's next. That's it. So in this way, at the end of the loop, the trav is node to be deleted, and temp is node before that. अब क्या करना चाहिए? अब क्या करना चाहिए? Simply you want to bypass that particular trav node, so simply go ahead and say that temps next is equal to travs next. Temps next is equal to travs next. It is in front of you. Is this all right? Is this all right? सर उस नोड को डिलीट नहीं करना है. Please note the trav node will be automatically garbage collected. will be garbage collected. आपको डिलीट करने के कष्ट नहीं करने हैं. It is that easy. But by the way, ये कोड फेल कब होगा? इस कोड में what would be the special conditions? Can you guess the special conditions, please? What would be the special condition? If your list is empty, you need not to traverse. Second special condition. You are trying to delete the node at the first position itself. You are trying to delete the node at the first position. Why you are traversing? Oh, that is again not needed. And third thing, if the position itself is invalid position, so there are plenty of cases. अब एक बात बताओ, if the position is invalid, what do you want to do? If position is invalid, what do you want to do? I'm very sure you do not want to delete that, no? ऐसा नहीं कि दे position अगर गलत है तो last node को delete कर देते हैं. No, that is not a good idea. I want to throw the exception. So let us just go ahead and put it over there one by one. So special case number 1, if list is empty, if list is empty नहीं, if position equal to 1, delete first node. Correct. The special case number 2, if list is empty or position is less than 1, then throw exception. And third thing, if what is third special case? Special case number 3, if position is beyond list length, what is to be done? Then again throw the exception. You continue further. You start with the first. If position is equal to 1, you simply want to make a call to the function, let's say del first. Oh yes, you can handle that, not a problem. You continue further. If head is equal to null or position is less than 1, you want to throw the exception. How do you throw the exception? Oh, we already know that. It is through the exception. I can simply say that list is empty or invalid position, whatever. That we are done. And a third thing, agar if you are going beyond the position, 100% your trav is already becoming null. If trav is null, again you want to throw the exception saying that this position is not available. So you can simply say invalid position. That's it. So will it work? Yes, it will work. आप लोग जब लैब में जाओगे आप इसको रन करके देख सकते हो. मैं फिलहाल एक बार क्विकली यहाँ पर रन करके दिखाता हूँ. लेट्स दैट 3 10 3 20 3 30 3 40. You see display or 10 20 30 40. Let me delete the node at the third position. I delete the node at the third position. 7. Delete the node at the third position. You find that, oh, 30 is gone. Now it is only 10 20 and 40. I hope this is working well. इसको ट्राई कैच में लिखना है वो आप लोग लिख सकते हो. There is absolutely no problem. Is this all right? Is this comfortable? So this is all about how we go for a single linked list. I know that I have taken enough slow for this linked list, and I would say that I know that आज आपका 31st होगा, कुछ बहुत बड़े बड़े काम रहेंगे. So ensure that before you do anything else, linked list paperwork and its code. Make yourself comfortable. If you do not get time, very important, if you do not get time to do the paperwork and write the code, do not come for tomorrow morning session. Tomorrow morning session is only for those people who have completed this part. So जिन लोगों का पेपर वर्क, सर हमको पेपर वर्क करने के लिए टाइम ही नहीं मिला, वो 31st के पार्टी में रह गया, तो डोंट कम फॉर टुमारोज लेक्चर, देन योर पार्टी शुड कंटिन्यू इवन टिल टुमारो. Don't come for tomorrow's session. It will be wastage of your time, your frustration, and my frustration as well. Correct? Any questions are there? If someone has got a question, you can wait. If you have no questions, you can leave. Thank you very much. See you tomorrow on a new year. Bye bye. So, good morning, everyone, and Happy New Year to all of you. As in the last session, we talked about kind of a bubble sort. We talked about insertion sort. At the end, someone asked me the question that which sort is to be used when. Obviously, I answer it, but definitely we will look at the comparison of multiple sorting algorithms when we learn all 6 sorting algorithms. Right now, we discuss only 3, so there are 3 more yet to come. So once we finish with the other 3 sorting algorithms, probably we can discuss there what basically the difference, or like which one is better in which scenario. Yes, we will talk about. If I at all forget, remind me. Anyway, then I'm just continuing further. Then we talked about kind of linked list. Yesterday we tried to go absolutely slow, where we try to make how to go with like a singly linked list. And to make a singly linked list, we have written certain functions. The functions that we written was like kind of a display function, add first function, add last function, add at given position function. After that, we had like a delete function, at a position, delete first, delete last. Probably I left it for you. So yes, we will quickly go back. We will talk about the delete last function as well, if at all you could not make, or some of you could not make it. So we will talk about that. And after delete last function is done, then we will move on to the next type of linked list. For today's lecture, it is really required that yesterday you people have taken time, you people have drawn diagrams once again, and from the diagram you are able to build your own code. So that visualization of diagram and then building a code, I know that it takes time, but I guess you had enough time yesterday, that whatever time that you get, so that is more than sufficient. If you could really went through all the algorithms and do it one by one, I believe today you should not have any problem. If at all you had done some shortcuts yesterday, you need to pay off, and nothing much I can do for that. Anyway, I'll just go ahead and we'll quickly talk about the delete last function. The delete last function, if you want to implement it, yesterday I told you that we can always follow the 2 pointer approach, even though we can do it as a single pointer as well, I know, but still, for sake of clarity of a code, to make code more readable, not the fancy one, I'll go for like a 2 pointer approach. And the 2 pointer approach, what all we need to do, I'll say that one is trav pointer and temp pointer, that blue color temp pointer is running behind it. So we need to go step by step. We need to go to the last node. Yesterday, the deleted position, we done a counting, I is equal to 1, I is less than something. But now we do not really want to do the counting. We want to go to the last node. And how do I go to the last node? So to go to the last node, all we need to do is that go ahead. We need to so temp is equal to trav, temp is equal to trav, and then trav is equal to trav's next. Again, temp is equal to trav, and trav is equal to trav's next. Again, equal to temp is equal to trav, and trav is equal to trav's next. Now somewhere you find that the trav is reached to null. Sorry, my mistake. Somewhere where you find that the trav is reached to the last node. If at all you find that the trav is reached to the last node, this is the node that you want to delete. And if this is the node that you want to delete, if this is a node that you want to delete, what you should do? What you should do? Can you please tell me diagrammatically what should happen in this case? अगर आपको लास्ट नोड डिलीट करना है तो आपको क्या करना चाहिए? Obviously उसका जो previous node है, उसका जो previous node है, that should become null. So it should point to null. It should not continue on to the next. That is what all you need to do. And that is the reason I said that you can go for two pointer approach. That makes it more readable. I repeat once again, things can be always done using a single pointer as well. Absolutely no problem. So I'll repeat it once again on paper. All I need to do is that I need to take two pointers. The pointer one, where the trav pointer through which I want to go to the last node, but the temp pointer I want to make it running behind it. So every time before I take trav to the next node, take temp is equal to trav, and then say trav is equal to trav next. Temp is equal to trav, and then trav is equal to trav dot next. You continue traversing until you reach to the last node. By the way, which node is said to be the last node? The last node is one whose next contains null. So I understand that this is a place I need to wait. This is a place where I need to stop. I do not want to traverse anymore. But if this node is a trav node, then the node behind it, temp node, it is just behind it. If you want to delete the last node, if you want to delete this last node, what should happen? The temps next should no more point to the trav, and the temps next should point to 0. And if you have done this, that is more than sufficient. You understand it very well that the trav pointer, the trav node will get garbage collected, isn't it? So that is all about logic. Let me just quickly go back. I'll purposefully write it in yesterday's code only instead of coming up with the new code altogether. So delete last, and then the code sharing that I have made on, it is for today. It is not for the yesterday's code. Anyway, I'll first finish this. आपने वैसे भी already कर लिया है, so you don't need a code sharing with this. Okay, it is a delete last function, and into the delete last function, I'm saying that I need two pointers. One is temp pointer, which I'm saying null, trav pointer, which I'm saying head. So what I need to do, the traverse till last node using trav, and and run temp pointer or temp behind it, right? This is what all I need. How do I do that? The last node, I understand trav dot next is not equal to null. Trav dot next is not equal to null. I can simply say trav is equal to trav trav dot next. Trav is equal to trav dot next. That's it. It is going to the last node, and that is fine. But wait, but before I go to the next node, every time I want to say temp is equal to trav. So this way I'll be able to reach to the last node, and temp is pointing to the second last node. Now what all I need to do? I need to go ahead and I need to add one more point. I need to delete the last node. So when last node in the sense now trav is deleted, the second last node, which is probably in this case temps, next should be null. And that is what all I understand. All I need to do is that temp dot next is equal to null. Note that last node trav will be garbage collected after this will function. So no pointer is pointing to that. So that is what all I need to do. Simply delete function. But again, we have not yet considered the special cases. So sir, what is special case over there? What could be the special case over there? A special case where my linked list is empty. If linked list is empty, if there is no node available, how do you delete the last node? A node ही नहीं है, तो delete first and delete last doesn't make any sense. So definitely, I'm saying that this is a special case. If list is empty, what I want to do? Just go ahead and throw the exception. This is what all you can do. So I understand this very well. Let us just go ahead and try to do that. Go ahead and try to do that. Ultimately, I can check it over here. I'll write it over here. The special case, if list is empty, throw exception. And how I can do that? If head is equal to null, throw new runtime exception. Done. Where I can simply put a message, list is empty. And other way around, if it is not, if it is not, the general case, it is simply delete the last node. That's it. So that is all we can do. Can we try to call this full function? Yes, definitely. We can try to call this full function. And how we can try to call this full function is over here. Instead of delete first, I want to make a call to the delete last. I said, to be frank, even deleting at a position also, there is a possibility that it might throw the exception. So if at all it is there, if at all it is there, we can always write a try catch for that as well. And we can even print a message over there if there is any exception, right? So all we are taken care over here. Let us just go back, try to run the program once, and then we will go on to the, like today's code as such. So what I want to do is that I want to add the node. Yes, 10, 20, 30. So three nodes are there, and ultimately I want to display the linked list. Yes, 10, 20, 30. My linked list is looking good. 10, 20, 30. Let me try to delete the node, last node, 6, and node is deleted. Okay, yes, 30 is deleted. Again, you can say 6, 20 is deleted. Again, you can 6, this one. Now there is nothing left in a linked list. So your linked list, oh sorry, I say del last. Something went wrong. I hope something went wrong, isn't it? Yes, one more special case is there. But one more special case is there. If your linked list has got a single node, then your code is not working. So why that code is not working? Have a look at this. Let me go again on a diagram. Let me again go on a diagram. This was like one special case was already there that we already talked about, and we had already written that. One more special case that I need to handle, that if at all the linked list has got only one node, if linked list has got only one node, 100, let's say whatever, data is not important. Now in this particular case, you understand it very well. In this particular case, take a look at this. You understand very well. In this particular case, if you want to delete a node, you need to modify the head pointer as well, and you want to make head is equal to null. You want to make head is equal to null. But the code that we have written, the code that we had written over here, we have nowhere modified the head pointer. And that is the reason the additional special case that I need to consider. What is special case? A special case 2, if list has only one node, only one node, make list empty. And how do you make the list empty? Just by making head is equal to null. Head is equal to null, which will simply, so all I'm trying to do is that I'm just trying to make this as null so that this node will be automatically deleted. And that is the only thing we need to do, nothing more than that. So yes, one special case is missing. So let me go ahead, write even a second special case. What is second special case? The special case number 2, if list has single element or single node, you can say single node, that make head null, make head null. So how do I check that? If head dot next is equal to null, if head dot next is equal to null, I understand that it is going to be a single node, क्योंकि पहले नोड हेड इज पॉइंटिंग टू द फर्स्ट नोड, पहले नोड के नेक्स्ट में ही नल आ गया, इसका मतलब ओके इट इज नल. What is to be done? Simply say head is equal to null, and that's it, nothing much to be done. Otherwise the rest of the case, yes, this is definitely available, is the general case. So now will it work? Let's go ahead, right? So you do bit of paperwork, you run your program, type your program, you automatically understand what should be special cases. Again, special cases are not to be by hearted, so you can always start with the generic code first. You can guess few special cases. Even though you miss a special case, there is not a problem. When you write a program, you can check it once again. If everything is going well, if something is missing, you can think on it. You can always alter the code. No one is stopping you, right? So I'm just going ahead. So 10, 20, I have just added two nodes, that is sufficient. Let me say 6, delete last. So 20 is deleted, 6, okay, that is good. And now even 10 is deleted. And then abhi ek bhi node nahi hai, it should definitely throw the exception. And yes, it is throwing an exception. I'm printing it, list is empty. That is good. So program is working well, right? So these are what I can say, the special cases to be considered, and things are going quite well. So you are able to see that. Obviously at the end, I will definitely share this blog code onto the Git. Today, since I want to work on a day 3, I just thought that कि old program में इसको पूरा करते हैं, ये आपको कोड शेयरिंग के ऊपर नहीं दिखाई दे होगा, मैंने अभी वहां पर कॉपी कर दिया है, just for your reference. Otherwise you can always do it at the end, and I'm very sure many of you had already completed this. Done. So जो primary functions होते हैं किसके, singly linked list के, that we have taken a look at. Now I had few questions onto this, on primary functions only. What is the time complexity? The code, all codes that you have got, yesterday's code, today's code. So what all is the time complexity? I was just talking to some of like February batch students somewhere. So a few students called me and asked them that, okay, what you are doing right now? So some of them that, "Nee, sir, we are preparing on data structure exam." So what you preparing for data structure exam? No, no, sir. We are just only talking about कि कौन से algorithm में कितनी time complexity आएगी. So we are doing add first, what will be time complexity? If you say add last, what will be the time complexity? तो सर ऐसा क्यों? नहीं सर, क्वेश्चन आते हैं ना उसके हिसाब से. तो एक बार it is worth going back, recap, understand what that algorithm is, and then we need to do that. Correct? So I'm just trying to tell you that exam point of view, time complexities are important. That is the reason first lecture we have talked about that. Yes, every function will have a different time complexity, and that is the reason we should be discussing कि कौन से फंक्शन को कितनी टाइम कॉम्प्लेक्सिटी लगने वाली है. मैं अभी सारे कोड फिर से नहीं लिखने वाला हूँ. गिट के ऊपर ऑलरेडी कोड अपलोडेड है आपके सामने. तो आई वुड ऑलवेज से दैट कि यू कीप अ कोड ओपन टू यू, keep code open to you, look at the code, and then we can talk about quickly one after another. The very first thing, by the way, what we are discussing a singly linear list. A singly linear list, the list looks something like this. Head pointer pointing to the first node, that is pointing to the second, that is pointing to the third, that is pointing to the fourth, and the last node is pointing to null. That's it. So this is a kind of a linked list that I'm trying to make. Now for such sort of a linked list, what would be the time complexity? Yes, let us get started and one by one. The very first, the time complexity of पहला फंक्शन हमने कौन सा लिखा था, डिस्प्ले फंक्शन. सो कैन यू प्लीज टेल मी व्हाट इज टाइम कॉम्प्लेक्सिटी ऑफ डिस्प्ले फंक्शन? ऑब्वियसली अगर 10 नोड होंगे तो आपको 10 बार ट्रैवर्स करना पड़ेगा. 10,000 नोड होंगे तो आपका लूप 10,000 बार चलेगा. सो डेफिनेटली डिपेंड्स on how many nodes that you have got. So directly proportional to the number of nodes, I can simply say that it is O of n. Let me go ahead. What is second? The second function that we tried was add last function. What we had done in add last function, see the code आपके सामने, comments आपके सामने. So we are first saying that, and always talk about general case. Do not think about the special cases. General case, you need to first traverse till the last node, and then in the last node you want to add a new node, correct? But then traversing till last node, again the loop is involved. I can simply say that time complexity is once again O of n. Third one. The third one we can talk about, I guess, add first function. Add first function, the add first function, where you find that there is no loop involved. अगर आपकी लिंक लिस्ट के 10 नोड की लिंक लिस्ट है या 10,000 नोड की लिंक लिस्ट है, एडिंग अ नोड at the beginning always takes the same time, always take the same time, constant time, you can simply say that it is O of 1. You can continue further, you can continue further, and we can talk about something called as a insert, or let's say added position. So what about added position? The added position, to be frank, it depends on the position where you are trying to add, isn't it? So ideally speaking, I can say that it should be the O of position. Ideally speaking, it should be the O of position. So position at which you want to add, probably those many times the loop is going to run. But sir, what about with respect to number of elements? Okay, if you are talking about with respect to number of elements, then then you need to take kind of average, जैसे हमने linear में किया था, and then on an average we can say that it is O of n by 2, O of n by 2 कि यूजर randomly अलग अलग जगह पे ऐड कर रहा है, so average लेके हम लोग बता सकते हैं it is of order of n. So to be more specific, it is a based on a position. जो आपका position होगा आपको उतना traverse करना पड़ेगा. To be frank, not उतना, that minus one आपको शायद उतना traverse करना पड़ेगा, but that is still fine. That is what all you can do. You continue further. कहाँ पर गया? Fourth हो गया. A fifth function. The fifth function that we tried was del first, I guess, and time complexity of del first. Del first, take a look at the code. Oh, we are not traversing at all. We are simply saying head is equal to head dot next. And if you are doing like that, then the time required is always constant, irrespective of how big your linked list is. Okay, that is good. And then you can just carry on further with something, let's say del last. Del last, just now we written. Del last, we need to again traverse till the last node, और second last node के next में हमको null करना है. So we can always say it is O of n. And on the similar line, we had written yesterday something called a delete at position. Delete at position again actually depends on what position that you are given. But if you do not want to go by the position, sir मुझको position में interest नहीं है, just tell me in terms of number of elements, then on an average I can say that it is O of n. That is absolutely possible. If you at all go with something called a delete all, now delete all, it all depends on implementation. It all depends on implementation. O of 1, I'm saying that it is for Java. It is for Java, जहाँ पर आप लोग directly you are using the garbage collector. अगर आपने ये कोड कभी C++ में अगर आपने डेटा स्ट्रक्चर किया है जहाँ पर आपको मेमोरी डिलीट करनी पड़ती है, अगर आपको मेमोरी डिलीट करनी पड़ती है हर एक नोड की एक्सप्लिसिटली, देन यू नीड टू एक्चुअली गो विद लाइक O ऑफ n, क्योंकि आपको हर एक नोड को वन बाय वन डिलीट करना चाहिए. Now, these are the special, at least the minimal functions we should be always knowing कि what are the time complexities. तो सर आप ये हर एक लिंक लिस्ट में बढ़ाओगे? नहीं, कोई जरूरत नहीं है. You have just got the idea of one linked list, that is more than sufficient. But sir, is there any way that I can make this linked list bit more efficient? Bit more efficient in few cases. Suppose that what if I have got a case what if I have a case जहां पर मुझको एडिशन एट द स्टार्ट और एडिशन एट द एंड बार बार करना पड़ता है. जैसे लाइक फॉर एग्जांपल अगर आप लोग जावा का कलेक्शन देखते हो, जावा के कलेक्शन में जो ऐड मेथड है वो बाय डिफॉल्ट एट द एंड ही ऐड करता है, करेक्ट? सो इफ एट ऑल आई एम वरिंग अबाउट दैट काइंड ऑफ सिनारियो कि जहां पर मुझको एडलास बार बार करना पड़ता है, अगर आपको एडलास बार बार करना पड़ता है एवरी एवरी टाइम, यू आर ट्रैवर्सिंग till that last element and then adding there, I'm saying that this may not be a very good idea. This may not be a very good idea. So sir, what we need to do? Is there any trick that we can play? Is there any idea that we can follow? Yes, definitely you can have some tricks. Definitely you can have some ideas. And the idea that is very commonly followed, is that we do not make a linked list with only head pointer, but we also make a linked list with the tail pointer as well. So we try to maintain not one pointer, but we try to maintain two pointers. One is a head pointer, another is a tail pointer. And what is the advantage of tail pointer? The typical advantage that you get it with the tail pointer is that You want to add a node at the end. You want to add a node at the end. Adding a node at the end becomes really fast. So how adding a node at the end becomes very fast? Now you understand that in this particular case, डायग्राम आपको सामने दिख रहा है. अगर मैं आपको कहता हूं कि मुझको अभी ऐड लास्ट करना है, सी इट केयरफुली. अगर मैं कहता हूं कि मुझको ऐड लास्ट करना है, अगर आपको ऐड लास्ट करना है तो यू फाइंड इट लाइक से ये 50 है आपका और 50 का नेक्स्ट अभी नल है. दिस इज न्यू नोड. तो अर्लियर हम लोग क्या करते थे, हम लोग पहले लास्ट नोड तक ट्रैवर्स करते थे. हम लोग पहले लास्ट नोड तक ट्रैवर्स करते थे और उसके बाद में हम लोग पहले लास्ट नोड तक ट्रैवर्स करते थे और उसके बाद में हम लोग उसको अटैच करते थे. लेकिन अभी आपको ऐसा नहीं करना पड़ेगा क्योंकि ऑलरेडी यू हैव गॉट पॉइंटेड टू द लास्ट नोड. Since already you have got pointed to the last node, see it carefully. Already you have got pointed to the last node. All that I can do, all that I can do, see it carefully. I need to just say one thing. Just point this to this. What I'm saying? Just point this to this. One step, and second step, make the tail pointing to the new last node. So hardly 2 lines of code should be more than sufficient, I guess. Tail dot next is equal to new node, and then you can say that tail is pointing to a new node, isn't it? Yes, that is more than sufficient. That is more than easy job. And what you achieved with this implementation? With this implementation, I said that my time complexity is now changed to O of 1. तो जहां कहीं पर भी आप लोग ऐसी लिंक लिस्ट बनाना चाहते हो, जहाँ कहीं पर भी आप लोग ऐसी लिंक लिस्ट बनाना चाहते हो where you are saying that कि I want to add the node at the end, and that is very frequent kind of operation. Now every time you writing a normal linked list, every time you are traversing there and then adding it over there may not be a good idea. May not be a good idea. At that time, you should strictly focus that you should create another tail pointer, and we need to manage that. I repeat once again. What I said is that if you take a look at this, you want to add a node at the end, you want to add one node at the end, all efforts that we are doing is that we need to take a trav pointer, and then we need to traverse, and then we need to traverse till the last node. And then we need to traverse till the last node. Once we traverse the last node, then we say that trav dot next is equal to new node. Definitely this works. Again, it is not about the output. But if your linked list has got 1 million nodes, you need to first traverse through that 1 million nodes, and then you are adding a new node. It is time consuming. I'm saying that the time complexity is kind of O of n. तो सर कोई आसान रास्ता है? आसान रास्ता ये है, why don't you go ahead and you add a tail pointer with it? You add one tail pointer with it. So within a linked list, do not maintain only head pointer. You also maintain a pointer to the last node. Also maintain a pointer to the last node. So every time, every operation that you're doing, you need to keep a track. The last node you need to manage. The tail pointer you must be managing. And then if you have got tail pointer, what is the advantage that you get? The advantage that you get is that adding a node at the end becomes super fast operation. Super fast operation matlab you simply create, let's say, new node object. You simply create a new node object, then अब आपको ट्रैवर्स करने की जरूरत नहीं है. Already you have got a pointer to the last node. If you already has got a pointer to the last node, all you need to do is that last node के next में you can keep a new node pointer. Sorry, my mistake. Last node के next में you can keep a new node pointer. That's it. So ये वैसे भी idle last हो गया. But you need to remember that tail pointer should always point to the last node. So अगर आप लोग idle last कर रहे हो, then it is your additional responsibility that you make tail is equal to new node. So hardly 2 lines of code is more than sufficient to add the node at the end of the list, irrespective of how big your linked list is. Whether it is 10 element, whether it is 10,000 element, the time required is going to remain same, and then that is O of 1. Namrata, is that fine? Yeah. Someone is suggesting me that this will also speed up del last operation. This will कहाँ पर गया अमित? It is tell dot next is equal to new node. The next is a pointer to the node. Amit, next is the pointer to the node. Next is not pointer to the value. Our value is of integer type. करेक्ट. तो हमको पॉइंटर के अंदर हम लोग इंटीजर नहीं रख सकते. पॉइंटर के अंदर हमें पॉइंटर रखना है, रेफरेंस ही रखना है. राइट. हमें कहां पर था? नो प्रॉब्लम. हाँ, तो समवन इज सजेस्टिंग मी, मेरे को 2 बार किसी ने तो पिंग किया, so इससे डेलास भी फास्ट होगा. डू यू रियली बिलीव दैट डेलास विल बी फास्टर? टेक अ लुक एट द डायग्राम and tell me what the do you believe that Dellas will be faster with this? क्योंकि डेलास्ट में प्रॉब्लम ये है, डेलास्ट में आपको लास्ट नोड डिलीट करना है, नो डाउट ऑन दैट, बट एट द सेम टाइम आपको प्रीवियस नोड मॉडिफाई करना है. सो राइट नाउ यू हैव गॉट अ पॉइंटर टू द लास्ट नोड, you do not have a pointer to the second last node. अगर आपके पास सेकंड लास्ट नोड का पॉइंटर होता तो शायद डेलास्ट फास्ट होता, शायद डेलास्ट फास्ट होता. अब आपके पास कोई चॉइस नहीं है अदर देन लिटरली ट्रैवर्सिंग till the second last node, traversing till the second last node, making its next is equal to null, making its next is equal to null, and then making tail pointing to that second last node. So यहाँ पर ये आपको प्रोग्रामेटिकली हैंडल करना पड़ेगा, यहाँ पर ये आपको प्रोग्रामेटिकली मैनेज करना पड़ेगा. आपके पास इसके लिए कोई ज्यादा चॉइसेस नहीं है, यहाँ पर आपके पास इसके लिए कोई ज्यादा चॉइसेस नहीं है. दैट इज समथिंग दैट यू नीड टू अंडरस्टैंड. आई होप दिस इज प्रीटी क्लियर. करेक्ट. सो डेल्लास का टाइम कॉम्प्लेक्सिटी इट विल स्टिल रिमेन ओ ऑफ एन ओनली, क्योंकि अभी भी आपको सेकेंड लास्ट नोड तक ट्रैवर्स करना ही पड़ेगा. यहाँ पर कोई ऑप्शन नहीं है. हम लोग को सिर्फ एक ही एडवांटेज मिल रहा है, हमारा जो एडलास्ट है वो एडलास्ट फास्ट हो रहा है, और बहुत सारे ऐसी जगह है जहां पर एडलास्ट ऑपरेशन इज यूजफुल, एडलास्ट ऑपरेशन इज यूजफुल. तो सर एक जस्ट मॉडिफाइंग एडलास्ट विल डू? To be frank, no. You need to always go through almost each and every function, and you need to cross check whatever I'm doing, is it really useful or not? So let us just go ahead. Let us just go ahead and I'll come down to the today's code and we will do a little changes here and there. A few functions I will do, 1 or 2 functions, and few functions I will leave it for you. Sorry. जब तक ये चालू हो रहा है, कहाँ पर गया? हो गया, चलो. देयर वाज वन क्वेश्चन समवन वाज आस्किंग कि जब एग्जाम में क्वेश्चन पूछा जाता है व्हाट इज द टाइम कॉम्प्लेक्सिटी ऑफ दिस, एंड दे आर नॉट मेंशनिंग वेदर इट इज बेस्ट केस और वर्स्ट केस टाइम कॉम्प्लेक्सिटी, एट दैट टाइम व्हाट शुड वी कंसीडर? यूजुअली जब एग्जाम में ये मेंशन नहीं होता है कि विच टाइम कॉम्प्लेक्सिटी इज टू बी गिवन, यू शुड यूजुअली टॉक अबाउट द एवरेज केस टाइम कॉम्प्लेक्सिटी. आई होप दैट इज ओके. सो मेक अ नोट, अगर एग्जाम में आपको पता नहीं है विच वन इज टू बी यूज्ड और इट इज नॉट मेंशन कि हमको बेस्ट केस चाहिए, हमें वर्स्ट केस चाहिए, एट दैट टाइम द एवरेज केस टाइम कॉम्प्लेक्सिटी is generally followed everywhere. New Java project. So I'm going ahead. What is that? Singly list once again, because now this is a single linked list with the tail pointer. Don't create this. Okay. New class. New class. I'm writing, let's say, singly list once again under a package. Let's say Sunbeam. Okay, no problem. And inside this, I just copy pasted the previous code. Just copy pasted the previous code. अच्छा, कमेंट भी कॉपी पेस्ट हो गया. Yes, this is like a 1st January. It's good. चलो, let us continue further. Let's continue further. Error क्यों दिखा रहा है by the way? Copy paste उसको अच्छा नहीं लगा? चलो, पिछले साल का नहीं चाहिए, इस साल का नया चाहिए. Okay, sorry. The name of a file should be singly list main. Main जिस क्लास में होता है guys, उसका नाम चाहिए. What went wrong? तो गड़बड़ कर रहा हूँ, एक काम करता हूँ, न्यू क्लास सिंगली लिस्ट मेन, डन। अब ठीक है, all right. And now inside this, yes, I seen somewhere there are issues. Let us go ahead. Package name is Sunbeam, that is all right. I done import statement, that is also right. And then inside this single list is a class that I have copied from the previous, that is also right. The single list main, that is also all right. And at that, whatever the extra single list main is there, I need to remove that, and this is done. So I hope now it is all right. But then over here, I want to create a linked list with the head and tail. So let me write somewhere here. We are talking about a singly, we are talking about a singly, अरे चल क्या रहा है, कुछ तो गड़बड़ क्यों हो रहा है? Singly linked list with head and tail pointer. Pointer का हो, reference का हो, whatever, your choice. All right, this is done. And then I'm going ahead one by one. तो यहाँ पर changes क्या करने पड़ेंगे? You see that. Do you believe that any changes are needed in a node? Node के अंदर किसी कोई changes की जरूरत है? Not really. The node class still remains same. I hope you got enough time to go through the node class and see that. वैसे छोटा सा class था. But then, do we need any change into this? List class के data members में कोई change चाहिए? Definitely. अभी यहाँ पर सिर्फ head pointer है. I want to go ahead and I want to simply say private node tail. चलो, I also added a tail pointer into that. Obviously, if you are added both the pointers, you need to take care. Initially, you want to make head is equal to null, even tail is equal to null. That is good. What about display function? Do you believe that any change needed in a display function? Do we need any change in a display function? You can take a look at your linked list. ये linked list अभी भी आपको head से चालू करना है और आपको null तक जाके खत्म करना है. So आपको अभी भी head से चालू करना है, अभी भी null तक जाके खत्म करना है. I really don't think कि इसके अंदर कुछ करना चाहिए. Go ahead. As far as add first is concerned, do we need any change? Wait. नहीं, कुछ तो गड़बड़ है. Please note, what is the special case of add first? There was one special case of add first, जो हमको अलग से कोड लिखने की जरूरत नहीं पड़ी थी. If list is empty, don't you think that for the empty list, what about tail pointer? क्योंकि empty list जब होगा, जब लोग पहला नोड ऐड करोगे, the first node itself is the last node. Don't you think that? So if list is empty, the first new node itself is last node. So some extra efforts that you need to take over here. What extra efforts that you need to take over here? You need to also say tail is also pointing to the new node. A tail is also pointing to the new node. So अगर आपका link list empty link list है, अगर आपका link list empty link list है, whatever new node that you have added, now you need to take care this one itself is there. So I can always check that if head is equal to null initially, if head is equal to null, I can say that वैसे head is equal to new node वैसे भी हम लोग handle कर ही रहे हैं, उसके लिए अलग से कुछ करने की जरूरत नहीं है. But the special case to be considered over here, that if head is equal to null, then the new node itself is going to be my last node. So मैंने कहा ना, जब भी हम लोग लिंक लिस्ट में एक नया पॉइंटर ऐड करते हैं, you need to think in every function कि क्या इसके लिए भी कोई स्पेशल केस होगा, क्या हमें यहाँ पर भी किसी के साथ डील करना पड़ेगा. So we need to talk about it. Anyway, so that is like additional case we need to consider. कोई बात नहीं, we can continue further. What about add last? I guess now add last is something that I want to make it really fast. Special case, if list is empty, make new node as a first and not only first as well as last node of the list, isn't it? How do you make it? So head, and you simply say even tail is equal to new node. This is very simple. So मेरा पहला node ही जो पहला नोड आ रहा है हेड भी उसी को पॉइंट कर रहा है, टेल भी उसी को पॉइंट कर रहा है. बट इन जनरल केस ट्रैवर्स टिल द लास्ट नोड, ये वाला जो फंडा है इसकी कोई जरूरत नहीं है. नाउ व्हाट आई नीड टू डू इज दैट, यहाँ पर क्या लॉजिक लगाना पड़ेगा, अभी हम लोग वही बात कर रहे थे, एड न्यू नोड, न्यू नोड टू द नेक्स्ट ऑफ, to the next of last node, means what, tail node, and then update tail to new node, isn't it? Now these are like two lines of code that I need to write it. Simply go ahead, write it, tail dot next is equal to new node, and then you continue further. What is next? What is next? You simply say tail is equal to new node. I guess these are the exactly two lines we were writing 2 minutes back over here. Tail dot next is equal to new node and tail is equal to new node. Now that is what all you need to follow. That is what all you need to follow. Nothing much. Oh, this is done. So और कुछ करने की जरूरत है? I really don't think so. So मेरा add first function, add last function, and display function. At least these three functions we have taken care. We have taken care. Let us just go back and try to run it. Let us just go back, try to run it. Please note, बाकी सारे फंक्शन चलेंगे, मैं इसकी गारंटी नहीं दे रहा हूँ. तीन फंक्शन जो पहले थे वो हमने चेक किए, एंड आई बिलीव दैट ये तीन फंक्शन चल जाएंगे. Just rearrange it so that I can. Done. So let me say add first, let's say 2. Add first, I'm saying 10. 2. Add first, I'm saying 20. 2. Add first, I'm saying 30. 10, 20, 30 मैंने add first फैशन में ऐड किया है. Add first फैशन में ऐड किया है. So I find that it is 30, 20 and 10. Okay, that is good. What about add last? Is add last is working? It should. A 3, I'm saying 40. 3, I'm saying 50. 3, I'm saying 60. 40, 50, 60, I have added at the end. Have you added at the end? Yes, you find that the 40, 50, 60 is added at the end of the list. That's it. And now nothing much you need to do into this. I hope this is comfortable, and rest I'm giving it as your lab work. This is a lab assignment. Lab assignment. What is lab assignment? Do necessary changes. Do necessary changes in rest of singly linked list functions, methods. Do necessary changes in rest of singly linked list method to consider tail pointer. तो सर ये चेंजेस हम लोग कैसे करेंगे? Go ahead, add diagram, draw the diagram and see कौन से स्पेशल केस में आपको टेल को भी कंसिडर करना है, और जिन जिन स्पेशल केस में आपको टेल को कंसिडर करना है, do the necessary modifications in place. Do the necessary modifications in place. Chalo, Rajendra is having some question. Can we see performance anywhere in Eclipse? Unfortunately, no, Rajendra. By default, Eclipse doesn't show you any performance. There are specialized tools available in the market. What we call it the profilers. So profilers नाम के tool आते हैं, and the profilers tool can help you for taking a look at the memory, taking a look at the time that has been taken, even for the individual function उसने कितना time लिया वगैरह वगैरह. But again, they are never showing you the time complexity. They will always show you the time, the actual time that is required. And अब जितना छोटा लिंक लिस्ट हम लोग ले रहे हैं, हार्डली वी आर डीलिंग विद द लिंक लिस्ट ऑफ लेट्स से 3 एलिमेंट्स और 4 एलिमेंट्स. सो 3-4 एलिमेंट की लिंक लिस्ट में आपको प्रोफाइलर के ऊपर भी कुछ ज्यादा डिफरेंस नहीं समझ में आने वाला है. डिफरेंस समझ में आने के लिए यू शुड रियली हैव अ लिंक लिस्ट ऑफ 10,000 नोड्स, 20,000 नोड्स, एंड देन यू कंपेयर. देयर यू विल बी एबल टू एक्सपेक्ट, हाँ सर ये थोड़ा सा बेटर चल रहा है. आई होप यू गॉट द पॉइंट. Is this clear to everyone? You have any questions, you are welcome. I was just trying to tell you the improvements in a single linked list and talking about the time complexity and how we can modify that. Again, these are the interview questions. I repeat, these are the interview questions. So interview में से बहुत बार होता है that they are asking you, write so and so function for a linked list. You go ahead, you draw some diagram, you come up with some sort of a function, you tell that, okay, this should be the function. Interviewer is very happy that you are able to write the code. But then definitely after that, his next question will be, can you improve on this? Is there any possibility that you can speed it up, and then now you need to rethink. अच्छा यार ये मैंने लिख तो दे दिया, but then अगर मुझको इसको speed up करना है, तो what all other alternatives that I have got? What all other alternatives that I have got? And then again you need to go back and you need to rethink and then reorganize, and then you need to tell that. And that is the reason ये जो छोटी छोटी चीजें होती है, ये मैं आपको बता रहा हूँ. Let me tell you guys, data structure ये ऐसा मॉड्यूल है which is much more practical oriented module, not the concept oriented module. So as far as notes of this module is concerned, I may not be able to give you some good notes or something like that. जितने necessary चीजें हैं, like for example array versus linked list, I have written onto the slides. या फिर ऐसे कुछ चीजें हैं definitely जहाँ पर conceptual चीजें हैं कि trees के definitions क्या है, trees के terms क्या है, so that I can put it on a slides and that I already put it there. But when it comes down to the algorithm, so algorithm के notes नहीं होते. Algorithm होता है, और the person who do the paperwork more and more times and try to build his own code, he usually get comfort into the algorithm. That's it. Nothing much I can do. There are some conceptual topics also there कि like problem solving technique, greedy approach किसको कहते हैं, dynamic approach किसको कहते हैं. उसमें से कुछ जो चीजें practical के लिए जरूरत है, that I have already put it on my slides. और कुछ चीजें ऐसी होगी जो प्रैक्टिकल के लिए जरूरत नहीं होगी, जस्ट फॉर सेक ऑफ योर नॉलेज होना चाहिए, या कोई एग्जाम में कोई एमसीक्यू क्वेश्चन बनता है तो होना चाहिए. तो ऐसे कुछ नोट्स मैंने निकाल के रखे हुए हैं. आई बी एबल टू शेयर विथ यू सम टाइम लेटर, विच इज लाइक अ मोर ऑफ टेक्सचुअल डॉक्यूमेंट. सो सम ऑफ द वेबसाइट्स हम लोगों ने यहाँ से वहां से उठा दिया. Yes, whatever you are saying is correct. The confidence entirely depends on a practice. So people who do paperwork and people who write their own code, they are very comfortable with data structure, and the other ones they are very difficult, right? और कुछ है? ज्ञानेश्वर का कुछ कहना है, we learn linked list with interface, and in data structure also, if interviewer asks to write linked list, which one to prefer? Which one to prefer? See, पहली चीज तो when you go to the data structure interview, no one asks you write a linked list. This is never a question. The typical questions that I have always seen that कि write so and so function of a linked list, or assume that data is something like this and then you try to implement this. अगर आप लोग वो असाइनमेंट सॉल्व करते हो, मैंने असाइनमेंट दिए थे, उसके अंदर ऐसा कुछ तो एक असाइनमेंट है, दो नंबर्स का डिफरेंस निकालो, उसको राइट इट बिफोर दैट, दो नंबर का डिफरेंस निकालो एंड सेव इट बिफोर दैट. ऐसा काइंड ऑफ असाइनमेंट है. सो कभी कभी ऐसे होता है कि कुछ स्टैंडर्ड फंक्शन लिखने के लिए बोले जाते हैं कि do that kind of del last operation on doubly linked list. So at that time you should be able to write a code. Or sometimes कि given a linked list like this, I want this sort of operations to be done. Please go ahead and write a code for this. तो you need to write a code for that. Write a linked list. ऐसा कोई मतलब नहीं होता. ऐसा कोई मतलब नहीं होता. And when it comes down to the language, डेटा स्ट्रक्चर में यूजुअली लैंग्वेज कभी भी बैरियर नहीं होता. सो इंटरव्यूअर नेवर आस्क यू यू राइट अ पर्टिकुलर लैंग्वेज. सो एनीथिंग दैट यू आर कंफर्टेबल, you can always go ahead and write it. Or if you want, you can take a permission of a interviewer what exactly you are looking for. So should I write it in Java? Should I write it into the C language? Should I write it into the another language that I want? I hope Naneshwar you got the point. I would request if you have any questions, please put it on a public forum so that everyone can understand a question, and then probably I can answer. Otherwise, I need to follow the, the way Mahesh sir teach. So I can definitely, it is possible for me. I can keep your chat open, floating onto my screen where everyone can read it. But it will be always good that if you put your question public, so that when others are, when I'm answering, वो बचे हुए लोग, so the rest 300 people, they are going blank. ये नीलेश सर को क्या हो गया अचानक कुछ भी बकबक किए जा रहे हैं. तो ऐसे नहीं होना चाहिए. करेक्ट. सो मुझको पहले लोगों को क्वेश्चन बताना पड़ता है कि ज्ञानेश्वर ने ये क्वेश्चन पूछा है और फिर उसका जवाब मैं ये दे रहा हूँ. सो बेटर यू पुट इट ऑन अ पब्लिक फोरम. यू आर मोस्ट वेलकम. I don't worry. If your question is too intelligent that I could not answer, I will definitely say that. I will search it later and tell you. If your question is very stupid, that is also fine. We are not even anyway extraordinary. We are the average people. So average people can always ask the average questions. So there is absolutely no worry about that. तो नथिंग टू शाय एंड नथिंग टू वरी अबाउट. कोई बात नहीं. हम लोग कहां पर थे? सो आई वाज टेलिंग यू, ए बाय द वे, योर असाइनमेंट इज क्लियर टू यू? हेलो, इज असाइनमेंट इज क्लियर टू यू? आई होप यू विल बी एबल टू डू दैट. कोई बहुत मुश्किल असाइनमेंट नहीं है, प्लीज गो अहेड एंड डू इट बाय योरसेल्फ। बाद में ये मत बोलना सर ये नीचे वाले फंक्शन चल नहीं रहे, नीचे वाले फंक्शन चल नहीं रहे और कुछ कुछ स्पेशल केसेस में वो नहीं चलेंगे, ये मेरे को अच्छे से पता है, एंड दैट इज द रीजन इट इज गिवन एज असाइनमेंट। दैट इज द रीजन इट इज गिवन एज असाइनमेंट। और वो असाइनमेंट कैसे कंसिडर करना है, ये मैंने ऑलरेडी आपको एक दो जगह पे कंसिडर करके बताया है कि हाउ यू नीड टू कंसिडर दिस, हाउ यू नीड टू कंसिडर दिस। सो यू नीड टू ड्रॉ द डायग्राम एंड you need to come up with the solution. Chalo, let us continue further. And now the next one we want to talk about is kind of a singly